Data science and any data-inspired and data-driven science is so critical right now. More and more decisions are made based on data. The amount of data that we gather every day and the insights that the data can provide us is just growing exponentially, and that is no exaggeration.
The market for data science and related areas like AI is booming.
It is so important to have women in artificial intelligence in the area of data science and also in leadership roles. It's being able to use data to solve issues and understand bigger problems. It's critical. And we need women in these roles. Every individual brings their own perspective. And so we need to make sure the entire workforce is represented.
And the good news is there's so many jobs and many different ways to combine their passion area and their skills in data science and get involved.
I would like you to say, what are the problems in the world that absolutely have to be changed? And, can you individually, given all the amazing background that you've had so far and all the education that you've got so far, what are the unique things that you can do to change the world towards that mission? And then think of the technology.
If that is going to become completely data-driven over time, then you can't miss that opportunity. You've got to join in and have your say.
If you're not looking at the data from all sorts of different angles, then you could introduce a lot of bias. So it's really, really important that we have around the table all genders, all races, all backgrounds.
We can't ignore social and structural problems. We can't just go in a corner and write some code and read math and then that's the solution, right? We can't do that. So we have to think about who is being affected by these algorithms.
Welcome to WiDS!
When we first started this conference, we never would have imagined that we'd be sitting here today with over 200 regional events. We've got over 500 WiDS ambassadors worldwide. Many of them are women, but we've also got a lot of men. And these are people who are just passionate about inspiring others within their community. We're in over 60 countries, and year after year, we're blown away.
Let's make this next decade the Women in the Data Science decade.
What I love about it is that growth is viral. That people will attend one event in one city and then they'll want to bring it to their cohort or colleagues the next year.
This type of industry can be done everywhere, so it should be accessible to everybody. And this is one of the reasons why I love that we are global with WiDS.
So we wanted to create opportunities for women to inspire, educate, and support women at many different times throughout the year. And one way that we decided we could do that was through a datathon every year, which is a predictive analytics challenge using real-world data. We have over 900 teams from 85 countries, and that's in every continent except Antarctica.
When we started WiDS in 2015, we had no idea this was going to be a global movement with tons of international events and a datathon and a podcast show and now outreach to middle school and high school. It's just been such a ride.
Our latest endeavor is to work on some materials that we can hand off to teachers in schools around the world.
This has provided a platform for literally hundreds of women, if not thousands of women, to have an opportunity to be heard.
But the truth is, these are really simple experiments, but they had profound impact because they empowered someone else to be able to do their job better or to be able to take that message.
5 years ago, when we were sitting around a coffee table thinking about what WiDS could be, I never in my wildest dreams thought it would grow so far and so wide around the world in just 5 years. What I'm most excited about is the next 5 years, because I think this is really just the start.
A very good morning to one and all. Hope you all are doing well. So this is the video of the Conference of Women in Data Science in Stanford University. And here we are today organizing Women in Data Science Mysuru, an independent event to coincide with Women in Data Science Conference held at Stanford University and an estimated 150 plus locations worldwide. All the genders are invited and are here to attend the Women in Data Science regional events to celebrate, appreciate, and glorify outstanding women doing extraordinary work across the globe. So this Women in Data Science Mysuru event is organized by Ms. Usha Rengaraju. She is India's first woman Kaggle master, and she takes a strong lead to organize and conduct talks and events that you always see on our channel. So you can get in touch with her at our Twitter at Rengaraju. She leads around 8 communities in Bangalore and Mysuru. You can see the list out there, and you can reach out to her anytime. She plays an avid and important role for making these events a huge success and a dream come true. WiDS Mysuru is organized in collaboration with 4 major universities, mainly NIE Mysuru, VVCE, GSSS, and GSSS. They have their own organizing teams. So this is the organizing team of GSSS Mysuru. We have the NIE Mysuru team, as well as the VVCE team. The organizers of these teams have played an immense role and supported us vitally. We appreciate their efforts and continued support. This here is the core team of WiDS Mysuru, a huge team which works with immense coordination and dedication towards making all the events a huge success. From marketing to designing to anchoring, this team has worked unanimously under the guidance of Usha Rengaraju ma'am. So our team consistently organizes such events throughout, and to keep yourselves updated, you can stay tuned and catch us up on the upcoming plans on our meetup pages. The links are put up here, so you can stay tuned to keep track of all the upcoming events. So don't miss up on anything. So with this note, let us commemorate our event by introducing our first speaker, Srujana. I would like to call Shashank, my co-team member, to take it over from here.
A very good morning to one and all watching us. Thank you so much for being here. And on that note, let's get started. And we've got our first speaker, Ms. Srujana Kaddevarmuth. And today she's going to be talking about data science for sustainable development goals.
Hello everyone, my name is Srujana Kaddevarmuth. I lead the data science charter for a multinational corporate in the Bay Area in the United States. I serve on the board of United Nations Association, San Francisco, chair the Women in Machine Learning and Data Science Bangalore chapter, and I'm a WIDS ambassador. I started my career 12 years ago as a data scientist with Data Energy Research Institute. It was there that I got the first-hand exposure working on real-world problems that involved analytics, and I was totally fascinated by the potential of this field. For most part of my career, I worked with corporates which use data science for either profit maximization or loss minimization. In the course of path, while working with these corporates, I got to work on certain very interesting projects on a pro bono basis to leverage data science for environmental protection, forest conservation, and combating human trafficking. Working on these projects helped me realize how data science can be leveraged and can have humongous impact to environment, society, and communities in a positive manner. Thus, I'm actively involved in exploring avenues of leveraging data science to attain global sustainable development goals that can transform the world in a meaningful way. So now, what are these global sustainable development goals? Global sustainable development goals are a call for action by all the countries, maybe rich, poor, or middle income, to promote diversity, specifically to promote prosperity as well in this planet. They recognize that ending poverty must go hand in hand with strategies that build economic growth and address range of social needs, including education, health, social justice, and job opportunities, while tackling climate change and environmental protection. More than ever, the goals provide a critical framework for COVID-19 recovery, which is a need of an hour. COVID-19 is spreading human suffering, destabilizing global economy, and negatively impacting lives of billions of people across the globe. The pandemic is an unprecedented wake-up call, laying bare the deep inequalities and exposing precisely the failures that are addressed in the 2030 Agenda for Sustainable Development. The 17 goals that you can see here on the screen are all interconnected. And to leave no one behind, it is important that we achieve them all by 2030. Now, how can we use data science to achieve these global sustainable development goals? The volume of the data that is getting generated every year is just humongous. By some estimates, 90% of the data in the world has been created in the last 2 years, and it is projected to increase 40% annually. One of the key roles of United Nations and other international organizations is setting principles and standards to guide collective action around safe use of big data for development and humanitarian action, especially within the global community and across primarily using the common norms. It promotes development of high-impact analytics initiatives of United Nations Secretary General on data science. One of such initiatives is Global Pulse. It is primarily a development of analytical solutions for United Nations. Data science can be leveraged to attain sustainable development goals. For example, we can use data science for satellite remote sensing that can be used to further analyze the data and design sustainable cities. Genetic mapping of health indicators data can also be used to predict the health conditions and provide timely treatment and prevent spread of some infectious diseases, such as the pandemic or the COVID-19 disease that is been affecting multiple people across the globe. Similarly, also forms and e-commerce platforms have a lot of these transaction data, which can be analyzed to reveal the pace of transactions and transitions to energy efficient products. To ensure that the access to the insights from big data across industries is widely available, Global Pulse has been working with private sector to operationalize the concept of data philanthropy or data democratization, and many sectors are contributing to social, economic, and environmental causes. Over the next few minutes, we'll go over the applications of data science for social good across government organization, corporate, not-for-profit, and non-government organizations. And why do we think that it is important? And what's the context of why we believe it's important? Many top organizations or corporates are investing resources in applications of artificial intelligence for good in some areas that are aligned with their organizational strategy. Google, for example, has an AI Impact Challenge, a program that has dedicated around $25 million in pool in credit and cloud consulting for this program. It calls organizations across the world to submit amazing ideas and selects the best ideas amongst that, and that can be showcased and primarily selected across different pools that are currently existing and that have submitted the ideas. Now, how do they select these pools? And how do they make sure that the awards have been given to the organizations that really can bring some amazing ideas to life? For that, it calls for organizations across the world to submit their ideas on how they could use artificial intelligence to help address societal challenges, and selects just few applications and supports them to bring them to life. Similar to that, even IBM Research Labs offers Social Good Fellowship. This program was launched in the year 2016 and executed around 28 projects from detecting new pandemics and diseases and understanding the causes of opiate addiction, recognizing hate speech using all its homegrown technology like Watson, which is a cognitive computing system. Similar to this, even Microsoft has a holistic program dedicated to different initiatives, which can be categorized around 5 different categories, specifically around AI for health, earth, accessibility, humanitarian action, and cultural heritage. They provide multiple grants to organizations working in these areas and partner with them closely to support these initiatives, while simultaneously driving adoption of their inbuilt cloud computing technologies like Azure. Their Artificial Intelligence for Earth Innovation Grant, according to me, is a flagship challenge, primarily because it is done and led in partnership with the National Geographic Society to address certain very important aspects such as climate change issues and biodiversity challenges. Now, moving on to the government sector, some of the agencies like California Natural Resources Agency has a lot of historical data and has carried out huge endeavor to tag this data in the recent past. And these tagged data sets are made available publicly to drive research and insights. They have a visualization dashboard that are hosted on their system that can be used by public to understand the patterns of either forest covers or water reservoirs. They call for projects and certain reports and recommendations from few to select academic institutions on initiatives involving community wildfire prevention and mitigation, watersheds, and biodiversity. Similar to that, Ocean Protection Council has many data science, analytics, and Internet of Things projects on detection and quantification of marine pollution, sustainable fisheries, and climate change, to name a few. United Nations associations as well as the agencies also have many curated data sets that are made publicly available on their website for general public to foster democratization of data, analytics, and data science. They also welcome collaborative projects with academic institutions on attaining global sustainable development goals. Now, let us look at some examples of how data science can be used for sustainable development, and also a case study on applications of data science for social good. Climate change is disrupting the pristine ecosystem around the Western Antarctic Peninsula, a globally significant center for biodiversity based on different species that are present in that particular ecosystem. There is presence of krill that provides sustenance for many other species. Many of the world's whales spend their summers here as their primary feeding grounds. By monitoring the size and the health of whales, it's possible to gain insights on the abundance of krills and the ecosystem as a whole. Satellites and drones now enable vast amounts of images and video data that can be captured on whales, which is collected in a timely fashion. And now, more than ever, it can be processed in a very efficient and effective manner. The Duke University has a mobile robotics and remote sensing lab, and it is developing machine learning models on Microsoft Azure that can manage this massive amounts of data and quickly provide statistics needed to help further research and expedite these environmental protection efforts. Patrick Gray, a marine scientist with Duke University's Marine Robotics and Remote Sensing Lab, very popularly known as MARS, which is led by Dr. David Johnston, is a member of one such research team which is monitoring whales in Antarctica. Mars Lab is training machine learning modelers to identify whale species, looking at the imagery and calculate their sizes from length and girth visible. A trained neural network can do this work in a couple of seconds per image or a couple of thousand images in an hour. That speed will enable them to process and analyze massive amounts of data they bring back from Antarctica on a timely basis in a regular fashion, gaining useful insights to help direct further research and environmental protection and conservation efforts. Now, let us look at another example of social impact challenge that is being led by Google. As a part of this challenge, Google looked for projects across the globe, ranging for social impact domains and levels of expertise, from organizations that have experience in artificial intelligence or have that capabilities in-house, to those which just have amazing ideas but do not necessarily have AI capabilities on how do they bring these ideas to life and put these ideas to better use. From that search, they selected around 20 organizations that encompass the breadth of impact of artificial intelligence that has to offer in terms of providing amazing solutions that can help further improve the societal situations and conditions. One of the grantees of this was Wadhwani Institute of Artificial Intelligence for Social Good. They primarily are focusing on cotton fields in the rural India. Now, as we know, cotton is one of the largest cash crops grown globally. It is India's third largest crop after rice and wheat and has 75% of it grown by smallholder farmers who struggle with uncertainty in yield and income. One of the critical challenges that they face is inability to manage pests despite heavy usage of pesticides. Wadhwani Institute for Artificial Intelligence has built a solution for this problem. Using features generated from convolutional neural network, the system first determined whether that image is valid or not. And if it is valid, those features were then used to detect and count the number of pests that were present on that particular crop. Using that count with the help of guidelines set by certain entomologists, the system recommended an action to farmer whether to spray or not to spray the pesticides. One of the salient features of this solution, according to me, is that in the cloud, the fully trained network is around 250 megabytes in size. Using a combination of network pruning and quantization, however, this team has been able to compress that model to approximately around 5 megabytes in size, suitable to run on even a low-end smartphones. Specifically, the rural people in the rural areas of India own such low-end smartphones, and generally internet connectivity is an issue in this area. But this solution helps to overcome both of those challenges. Now that we saw a few of these examples and use cases, let us look at data science for social good trends in the academic and non-government sector, as there are quite a few fellowships that are being offered by a few of these universities in the space. Few of the academic institutions have invited some of the very well-structured programs inviting amazing fellows. They have initiated such structures. Primarily, these programs are either fellowship programs or the summer internship programs in the space. For example, Chicago University, they have a paid summer intern to train aspiring data scientists to work on data mining, machine learning, big data, and data science projects with social impact. Working closely with government, not-for-profit, as well as non-government organizations, fellows who are enrolled in this program take a real-world problem, which could be in the space of education, health, energy, public policy, safety, transportation, economic development, and international development. And then work on that and make sure that they bring it to fruition and completion within the stipulated time frame. Stanford University and Carnegie Mellon University also offer similar 3-month program with full-time mentors within certain strategic areas of interest in their organizational fields. Now, these programs are interesting and important because the mentors are highly dedicated and they spend quite a lot of time training the data science enthusiasts and providing the right guidance and hand-holding, giving them the exposure to the right tools and techniques so that they can excel in this field. Now, let us move to the non-government sector. Data science is a resource-intensive field and needs good amount of funding. Hence, the not-for-profit organizations or non-government organizations that are working in this space most often than not partner with corporates, government agencies, and alike to do some impactful work. Global Emancipation Network is one of the NGOs that is making great strides in the space by combating human trafficking through data analytics and partnering with public and private organizations, enabling very effective and efficient victim rescue operations and informing policy changes. Global Emancipation Network primarily works in the domain of combating human trafficking, which is a very important societal problem and menace that human race is currently tackling. As a part of my previous organization, we collaborated with Global Emancipation Network. They had historical data and a database of image dataset of massage parlors across different geographies. And it was known that some of these massage parlors are the source of human trafficking. So the project was to look at these image dataset of these massage parlors and based on the patterns obtained from the training set and the information provided by the law enforcement authorities, we had to classify the test set into categories such as high risk, medium risk, and low risk massage parlors, so that the law enforcement authorities can use their limited resources to prioritize action on the high risk cases and mitigate and combat human trafficking. I believe such work is important because approximately 21 million men, women, and children are trafficked every year across the globe, generating an estimated $50 billion for traffickers and organized criminal networks. Such projects help mitigate these societal problems. Similarly, Human Rights Data Analysis Group uses data and analysis to identify and highlight human rights violations across the globe. As you can see, many examples of such happening in the Middle East and various other parts of the globe. Similarly, not-for-profit organizations and NGOs like United Way are applying data science for disaster recovery and resource management. Now, we got to know about certain United Nations Sustainable Development Goals, how data science can be leveraged in this area, and what are the recent trends in academic, government, non-government space in specifically applying data science for societal problems to create positive societal impact. Now, let us look at some of the important skills needed to succeed in the space of artificial intelligence for social good or social impact creation project leveraging data science. So McKinsey & Company did an exhaustive data collection and analysis in this space by analyzing potential applications for social good. They compiled this into a library of around 160 AI for good social impact use cases. They identified around 18 artificial intelligence capabilities that could be used to benefit society. 14 of them fall under major categories such as computer vision, natural language processing, speech, and audio processing. The remaining 4, which they treated as standalone capabilities, included 3 AI capabilities, such as reinforcement learning, content generation, and structured deep learning. They also included a category for analytics techniques, and generally this category cuts across all the verticals and pillars. Further to this, they would also emphasize on researchers and data scientists who can look into aspects of data security, bias, data privacy, and ethics, as seeking to further the social good with dangerous technologies would contradict the core mission and could also spark a backlash given potentially large number of people involved in such projects, as their stakeholders as well as stake is pretty high. As regulatory framework is evolving, there will be need for people who can build interpretable and explainable artificial intelligence solutions. And these skill sets are important to develop, especially if the data science enthusiasts or if the people interested in this domain are looking to upskill themselves accordingly. I have listed a few of these resources here, which talks about amazing fellowships, corporate programs, and organizations that we could watch as they are making some good strides in the space. Also, there are resources around the job site, as well as listservs one could sign up for, as well as the podcasts that feature amazing, highly accomplished men and women data science leaders who are making great strides and generating some amazing solutions for pressing societal problems. I hope you'll be able to utilize these resources if you're interested to proceed further in this domain. If you want to further explore and excel in this fantastic domain and applying data science for attainment of social good or in attainment of global sustainable goals, there are amazing opportunities and avenues that are available. And more than ever, world needs us to focus on using these technologies to bias our future towards a positive outcome of our society, or to use the data science as well as the artificial intelligence applications to create humongous positive impact for the society. I hope this session was thought-provoking, and if you have further queries and if you need to get in touch with me, you know where to find me. These are the contact coordinates. You can either get in touch with me over the email or over LinkedIn. I hope you enjoyed this session, and I hope you have the great rest of the conference. Thank you so much. Have a good day.
Thank you so much, ma'am. That was a wonderful session. And with that said, let's move on to our next speaker. That is Ms. Eleonora Nazander. And she is Advanced Analytics Manager at Bain & Company. And today she's going to be talking about key driver analysis of customer experience.
Hi all. Hi all, my name is Eleonora Nazander. I'm from Bain & Company, and today I will be talking to you about key driver analysis of customer experience. Congratulations, you are starting a new consulting project. A credit card company is looking to improve customer experience. They want to understand what factors may drive customer advocacy in their industry, and they ask you for help. Let's first talk about the dependent variable. We usually measure customer advocacy with NPS, or Net Promoter Score. It is a question asking how likely you are to recommend a company, a product, or a service to a friend or colleague. The answer ranges from 0 to 10. The respondents who give scores between 0 and 6 we usually call detractors, 7 and 8 passives, and 9 and 10 promoters. All right, how about our independent variables? At Bain, we have identified 30 elements of value. Those are aspects of value that a product or a service can bring to a customer. We identify functional elements like saves time, simplifies, quality, variety. Emotional elements that include reduces anxiety, rewards me, fun, attractiveness. Life-changing elements, include provides hope, heirloom, motivation, and finally there is self-transcendence. And you can notice that all these 30 qualities are positive, some positive elements of value that product or service can create for a customer. So we will run a survey where we will ask questions about NPS, and we will ask also questions about elements of value, how well each brand performs on these elements of value. Let's take a look at the data set. Here is a preview. So we have our dependent variable and we have 30 independent variables. All variables on the scale from 0 to 10. We don't have missing data here because we can force responses. But you can probably already guess that we will have collinearity in the data. This is because a brand that is doing well on one of elements is also likely to do well on other elements. If we go back to our pyramid, think, for example, about simplifies and organizes. Probably a product that is doing well on one will also do well on another. So that's why our data will have a lot of collinearity. Let's see how we can deal with it. So now, since we have collected the data, our task is to do the analysis. We need to rank 30 independent variables in terms of their relative importance for NPS. So how important they are for customer advocacy. How shall we approach this problem? Well, let's see what Google has to say about drive analysis. And it seems that multiple linear regression is often considered to be a gold standard here. So we would take coefficients from multiple linear regression and use them as indicators of variable importance. Well, that sounds pretty easy. Let's do exactly that. I have run multiple linear regression for us. It includes all of our 30 drivers. Let's examine the results. So I see quality showing up with strong positive coefficient. Also rewards me. Well, that's great. After all, we are working for a credit card company. This seems to make sense. However, I can also see a lot of negative coefficients here. What's going on? Reduces effort, saves time, makes money. Are they really negatively related to customer advocacy, to our NPS? Oh, actually, significance column. We have a lot of insignificant variables in this model, right? P-values are above 0.05, which means that coefficients are not significantly different from 0. Our model suffers from severe multicollinearity. What we should do is we should actually run stepwise linear regression. We should eliminate all insignificant variables from the model before we can interpret results. Okay, here we go. I did exactly that. So now we have just 30 drivers in the model. Quality and rewards me are still here, which is great news. That seems to be pretty intuitive. But how about attractiveness? Is it really a key driver for credit card industry? And also it has a negative coefficient. I would understand if it was not included in the model. Yeah, if it was not relevant, but why negative? So seems like we cannot really interpret coefficients of linear regression as variable importance. Also, here we have just 7 out of our 30 drivers. Does it mean that 23 drivers that were excluded from the model are not important? And only the 7 drivers are important? Or were some of these, the remaining 23 drivers removed because of collinearity with some drivers that have already been included into the model. That's probably true. So we cannot really interpret coefficients from linear regression as variable importance. It just doesn't provide a good ranking of driver importance. Yeah, some drivers that are important might be excluded from this model because of their collinearity with drivers that are already in the model. All right, what shall we try now? How about shade? Maybe a decision tree will give us great results. I ran shade for us. It seems like quality is the first item, first driver that shows up in shade. Okay, that's pretty intuitive. And then there are also splits based on reduces anxiety and badge value. Well, okay, fine. So we have 3 drivers out of 30 in this model. How about remaining 27 drivers? Does it mean they are not important? Or maybe they just don't add enough value to be included in this model after first 3 drivers have been included? It's the latter, right? So shade or card trees are very useful for visualizing interactions between variables. They're a great tool, just as linear regression, but they're a great tool for their own purpose. They don't provide a ranking of importance for drivers. So if linear regression and if shade failed for our purpose, what shall we do then? Well, the basic answer will be very simple. Why don't we do correlations? Here I ran Pearson correlations of each element or value of each driver with our dependent variable with NPS. Let's take a look at this ranking. Quality and rewards me appear to be strongest drivers. That makes sense, doesn't it? Then there is reduces anxiety, reduces risk, avoids hassles. And then on the very end of the scale, we have nostalgia, sensory appeal, and attractiveness. Well, this is intuitive ranking. It definitely makes business sense. Looks great. Are we done? Not so quickly. So Pearson correlation can be tricky. Let me show you why. Here I have 4 different data sets, and it's just fictional data. It's not related to our case. So these 4 data sets have exactly the same Pearson correlation coefficient. It's 0.7. If there would be young data analysts who have not created scatter plots, but who just ran correlation coefficient, he might have made a conclusion that there is strong linear relationship between 2 drivers, which would obviously be false. For dataset 1, yes, there is a linear relationship between 2 drivers. Dataset 2, 3, 4, no, not at all. Yeah, in dataset 2, all relationship is driven by one extreme outlier. For dataset 4, there is actually a strong non-linear relationship between 2 variables. So Pearson correlation gets fooled by outliers, and it cannot measure non-linear relationship between variables. It can only measure linear relationships. It also requires normal distributions for both of your variables, which very often will not be true. If Pearson correlation is not perfect, what else can we do? Well, it turns out there are 2 alternatives. There is Spearman correlation and there is Kendall correlation. And these 2 methods, they first rank all your variables, and then they calculate associations based on ranks. And you might notice here that Spearman and Kendall were not tricked by the outlier. They give scores very close to 0. And they also correctly said that dataset number 4 has very strong relationship. So they were able to capture nonlinear relationships. Okay, so let's see how these two methods perform on our data. Here I have 3 lines. Pearson, Spearman, and Kendall correlations of each of our driver with the dependent variable with NPS. You can see that actually they are pretty close to each other. Yeah, there is a little bit of variation, a little bit of change in the order, but overall they're actually quite aligned. So on our data, even Pearson correlation would have given pretty good results. But in your data, when you do analysis, you might have outliers or you might have stronger nonlinear relationship between variables. In that case, Spearman and Kendall will be a safer choice. Now, some of you might think, oh, there are also other methods for variable importance. Some of you might have heard about Johnson relative weights or partial correlations. Here, I added 2 lines corresponding to results of those 2 methods. What you can notice is that driver number 1 and driver number 2 flipped their places. Also, all other drivers are not so distinguished any longer. There is a large drop in importance after driver 3, and then drivers 4 to 30 are actually pretty close to each other. There is not much differentiation compared to our correlations. So what it means is that using partial correlations or Johnson relative weights, we would not be able to distinguish between drivers beyond first 3 drivers, which is of course a disadvantage. Yeah, maybe when giving recommendations to our client, we would like to recommend top 5 or top 10 drivers to focus on. So why these methods are not really able to distinguish between non-top drivers? The reason is actually that they penalize drivers for being collinear with other drivers. They are not able to give independent assessment of driver importance. Okay, so it seems like we found pretty good methods. We found correlation coefficients that give good ranking. Are we done now? Shall we use these methods? Well, maybe, but seems like there is a limitation. Let me illustrate what I mean. Let me illustrate it on famous Titanic data set. Here is a very simple decision tree model that is predicting Titanic survival. And here we have just 3 variables. So we have 2 continuous variables, its age and number of siblings. And first variable that appears to be the most important one is sex. And obviously it's a categorical variable. So if we had a task of doing driver analysis based on the Titanic data set, we would not be able to use correlation because we have some categorical variables and correlations can only be calculated based on continuous variables. So what can we do then? How can we assess importance of all drivers, even categorical ones? Let me introduce you a new metric that we have developed based on R². So let's feed random forest models to predict NPS from 1 driver at a time. In other words, we'll create 30 models. Each model will have NPS as dependent variable and driver as the independent variable. Then we will record R² from each of these models. And then this R² that we got from the models will be actually variable importance for the corresponding driver. So as a result, we will have a metric that is showing percent of variance explained in NPS by each of the driver. And here I'm showing to you how this new metric in red would compare to metrics that we created before using correlations. It's actually pretty similar. But the benefit here, is that we would also be able to score categorical drivers, not only continuous ones. And also, this metric is between 0 and 100%. So it's pretty intuitive to understand. And finally, let's give some recommendations to our client. We ranked all the drivers in terms of their importance for predicting NPS. Now we can recommend our top 10 drivers as ones that have most leverage, ones that have highest potential to improve customer experience. To conclude, when you do analysis, I would always like to start with end goal in mind. If ranking of drivers in terms of their importance is your goal, then please use bivariate methods, such as correlation or then R-squared. If your goal to understand confounding and interaction between drivers, then you will be well off using shade or multiple linear regression. And then finally, if your goal is to prediction, then you can use random forest, XGBoost, or any other model which will give you high accuracy. Thank you.
Thank you so much, ma'am. That was a wonderful session. And we've got our next speaker, Ms. Sayantika Banik, and she is a board member at Django Software Foundation. And today she's here with us and she's going to be talking about understanding communities.
Hi everyone, hope you're doing great. Today I will be talking about mostly around the communities part, which will not be technical ones, but you can sit back and relax. First of all, thank you so much, Women in Data Science Community, Mysuru, for giving me this opportunity to come up and speak to a greater audience. And I'm very grateful for that. A little bit about me. I'm Sayantika. So I currently work as a backend developer at Control Engine. In around that, I predominantly work in and around communities in India and across the nation. So I had one of the biggest open source communities as a board member. Also, I'm a mentor in other organizations like Founders for School, EverWise, and Learn It Girl, and other communities. So I have been there in communities around for a long time, and I have seen it both through the eyes of an organizer and also through the eyes of an attendee. So on the both of the sides, I have been there. I have seen what all we can learn, and also how can we give back to the communities. So I will be sharing a little what I have learned through my experience in last couple of years, and hopefully you can take back many lessons from the session. So today's topic is understanding communities. Might sound like, what is she even talking about? We all know what our community is. We sort of participate in day-to-day lives, and we are very much familiar of it. But to be frank, that there are many other people who are not familiar, or they are not familiar with the exact concept of communities, but they have a different alias version in their mind. which is exactly the opposite what a community should look like. There we have the both ends. So one who exactly knows what a community is, one who have not been ever introduced the concept of community, and other who have known it but of a different version of it. So here I will be talking about the tech communities, but communities are all around. If we live in a city and we have a group of friends who share similar interests, who have a similar thinking and how we think, and have similar vision and achievements, what we want to see in us, so we call them a group of friends. So they're a community for us. If you go to another city, you might have to find a community to adjust to it. So in tech, we see that we have communities which are basically, say, digital technology. So data science as a community. So Women in Data Science Mysuru is a community for us. There are a couple of other communities. So sometimes we say there's a TensorFlow community out there. There's a machine learning community out there. So we give it a name of a technology to group a certain group of people who share a similar interest, who have a vision that they want to achieve something in this field and want to go ahead and pursue their careers in the same, or are already working in these fields. First thing, communities are not just a conference or a meetup. Today, that the version we are seeing, that most of the people are very much looking communities at the angle of, oh, that's a conference, then it's a community. Something is a community and it's a conference, it's a meetup. No, it is a much deeper concept. We must not just relate a certain conference or certain meetup to a community. Both are very different from each other. A conference may or may not have similar interest of people coming in together, or most of the conferences do have that. So we can relate sometimes, but we should not always sort of go together with those terminologies together. So another thing I have seen in most of the times that when we sort of mix with a group of people, or mix with, say, machine learning communities, we just go, okay, I am a part of community, that's it, I have achieved whatever I wanted to achieve. But we should go a little step ahead and see that, okay, am I motivated being part of this community? Are those people competing with me in a healthy fashion? When I wake up today in the morning, do I have the urge to do something different? So if those similar thinking or those positive vibes are not coming, then I think we should take one step back and think, is this community right for me? Am I stepping into the right forum? Or is it what I would want to see in near future in myself and want to achieve myself? Is this helping me? We should definitely ask those questions. A community must motivate you to take the next step in your career, to be a better person, and to also help others in the same fashion that you seek help. Another time I have seen that it's not about just going and coming back and then we are done with it. Most of the main agenda of being a part of community is building up a long-time relationship, long-time connects. It might be just like, okay, we have like similar interest in projects. Let's start with the project and let's take it forward from there. Or it's just, it may end there, that okay, we are done. I'm okay now. I will switch to some other community or see some other project which is of my interest. But to have a sustainable relationship is a very commendable approach to be part of a community. So you should be involved, make meaningful long-term connects, which will not only help you today, but also near in the future. So I think this is what I have learned, that being part of a lot of many communities, both the sides, I was able to build a long-term connection, which until today I cherish about. Any ideas that come to me, or even just going around for a trek, it all boils down that we are all motivated together and we want to have a certain goal in our head which we want to achieve. So that sense we will get when you try to build a long-term connect and not just leave it hinged over there and moving forward. the most important part. Share your ideas. Be vocal. If you are part of a community and you are not speaking up, or if you find that there's something which is not correct, or there needs to be some improvements, you should much speak up. And if at all you're facing a lot of difficulties, you should not push yourself to extreme situation and then sort of speak up. If you're finding something is not falling in place and is incorrect, and you can see that there is a scope of improvement, every voice in a community is welcome. If it's not, then there definitely needs to be a change in the decorum or the way it functions. So each and every person should have the equal rights to speak up and have enhance the community. That's the whole part of being a community. So be vocal, present your ideas, and also learn from others when they are presenting their ideas. Together, it is a very good amalgam: learning, development, and also listening. Everything together binds up and gives you a flavor of the exact flavor that you want. Otherwise, it wouldn't be appropriate. So make sure that you speak and you don't push yourself to an extreme situation, and it's kind of evaluate your position way before that. The best part, never stop enjoying. Be yourself. When you see someone who is progressing and is done an amazing job, you don't have to copy that person exactly. That, okay, this is the journey of that person, I'll just copy paste and will certainly find that way, that the success that person has achieved. Rather, build your own success story. Learn from the mistakes of others, but build your own story, build your own success, build your own chapter. Be yourself. Don't try to push yourself being someone else. If you are yourself, just if you ask, if my shoe size is somewhere 7, so I don't want to push myself and wear some shoe size 10. I want to be myself, yet I want to wear an elegant footwear. So that's where it comes, like, be yourself and never stop enjoying. Enjoy yourself throughout your journey. Learn, cherish. If you fail, that's fine. Wake up next day, have the same energy yourself, say, today I failed. It's like most of the people don't even get the opportunity to fail. Never realize that there is something which is more important. Failure teaches you so much more than being a success story. If you're failing, that's a good sign that you are progressing day by day, and you are achieving something great. But there was something that was missing, which led to this. But if you have that in place, definitely next step is towards success. Keep learning. A success which comes being a part of community or being an individual is amazing. But stopping there would be a foolish act. Never stop learning. Because the world is ever changing. The world is never static. The lifestyle you're staying is never going to be the same than maybe the next day. The weather changes every day. So everything is a change, and change is the only constant that you can find around you. Why should you stop yourself from learning? If you love some technology, go deeper into that. Explore possibilities that has not been yet explored. Go to the depths. Try building something new, or try improving which is already been done. Certain things that you can learn through the communities part. Ask your peers or leaders in the community, like, what can I do? What extra can I do? Can I take up some open source projects where I can apply my thinking? Or can I do something entirely difficult? This is the place where you also build up your entrepreneurial thinking. It helps you to take a bigger step. It helps you to take responsive risk-making decisions that involves a certain amount of risk, and it also builds up that mentality of taking a risk and then building towards it and making it either a success or making it a journey that you enjoy. Respect your community. Always the motto of joining a community, you respect your elders, you respect your peers, the same way you should respect each and every person in the community. Everyone might be some may be very, very thoughtful, and some may be lagging a little bit of thoughtfulness, but you can always ask them, okay, it's, hey, maybe I found that this could be improved. Can you please take a look into it? That's the way how you communicate, and not disrespect someone. Always respect each other. Today, when we are in this beautiful meetup, a lot of efforts have been gone from setting the panel to building the creatives. And trust me, when I was doing all this work all together by myself, it's a Herculean task, and also you have a day job to carry on. Be respectful. Be respectful to your organizers, the people who are speaking, the people, also the audience, equally. Everyone who has put a little bit of effort making it a success, you should always respect them. That's how you will learn. Even our parents used to teach us, never disrespect someone. But somehow, in this world where we have seen so much of ups and downs, good and bad, we tend to forget all our basic teaching. Don't forget that. Be respectful to your community. Be respectful to anyone you meet around. If anything is not working, speak up. Be vocal. Be vocal in a polite manner, and things will definitely work out. Trust me. And now that you have achieved so much through communities, through learning, through meeting so many people, having a journey, looking at other journeys and learning, it's your responsibility to now teach someone else. Next time, you should be someone who is up for coming up on a stage and presenting your thoughts, how your journey has been. Or you can also mentor someone whom you feel have the potential that you see. I saw a lot of folks whom I have mentored that I saw myself in them. I was lost in my early career days, and I was roaming, okay, what should I do? I can pick up this, I can pick up that, I will pick up everything. That's one of the mistakes that we do. We tend to do many things and not focus on something which is very crucial to us. So the responsibility of mentor is not spoon feeding someone, but giving them the direction, and the mentee would automatically get that. So don't forget to give back to your community. And this is the most important lesson that I would like to give you from this session. And hopefully I will find that you are mentoring someone, you have presented your ideas which help others to pick up from you. And you can find me on my Twitter handle. If you have any pressing questions, I don't think you will be having any questions regarding this sessions, because it was very much everything that you knew already. What I tried was just remind you everything that is important, which is also important, I would say. Technology, skills, everything matters, but being respectful, having empathy towards others, teaching someone, giving back to community, keep learning. These are something that everyone needs to be reminded about, because they are equally important. And I hope so you will follow some of the aspects through this lesson. And thank you so much. And hopefully I will be looking forward to meeting some of you in future sessions. Thank you.
Thank you so much, ma'am. That was wonderful. And up next, we've got our next speaker, Ms. Sharmistha Chatterjee. She is a Senior Manager Data Sciences at Publicis Sapient. And today she's here with us, and she's going to be talking about fair recommendation systems. Over to you.
Yeah. Hope you're able to see my screen.
Yes, ma'am. We're able to see.
Yeah. So I have already been given an introduction, not going into too much details, but if you want to follow my blogs, you can go through techairesearch.com. So today I'll be talking about fair recommendation systems. So let's see what are the key takeaways of today. So we'll go briefly through the need for fairness in ML-based recommendation systems, what are the best practices, and then we'll look into how multi-sided fairness metrics and platforms that can help us to build a good recommendation systems that is unbiased and is fair towards everybody. Now, why do we need fairness in recommendation systems? So recommendation systems are like we recommend users different products, different items from Amazon, to think of Netflix, to anywhere, to even our daily grocery shop like Loyal World or Loyal City. Okay, so why we need fairness here? We see that there have been different acts coming up: Disability Status Act, Fair Housing Act, LGBT Fairness Act. Okay, so with this coming up, Age Discrimination Employment Act, with this act coming up, it becomes more to us that we treat the society more equally, giving good opportunities to the minority groups as well, and get to see that what they need, and are we giving the right recommendation items to these minority groups. So let's look at how ethical intelligence and fairness are linked, and how different eminent personalities have stressed the importance of fairness, and fairness have been incorporated in machine learning algorithms. So we see Professor Klaus Schwab, Executive Chairman of World Economic Forum. He is telling that we must address individually and collectively moral and ethical issues raised by cutting-edge research in artificial intelligence. And so it becomes important that it is not that we develop something in ML or artificial intelligence, we incorporate fairness, which will enable significant life extension, designer babies, and memory extraction for everybody, for all communities, even for minority groups as well as majority groups. And with that, having said that, there is an algorithm justice leaks founded by Joy Buolami of MIT Media Lab that has started the research on different kinds of image processing, that we don't discriminate Black people, we don't discriminate any any minority groups, studying for Africans, Black, and others who are who comprise hardly a few number in their communities. So we have to be very careful that we use ethical and inclusive artificial intelligence. And last but not the least, Sundar Pichai has already stressed the use of AI regulation from Alphabet. He's the CEO of Alphabet, that we should use AI regulation to enable fair marketplace, legal obligation, social responsibility, as well as business requirement or model. So every place, if we use fair AI or fair artificial intelligence, it will help us to have a fair place, legally, socially, economically, everywhere. So now, why do we talk about fairness? Where are the biases creeping in? We see that biases are creeping in from demographics, user characteristics, differences across different online and offline communities, platforms, some like Facebook, Twitter. Sometimes we see that we do have little bit of representation, very little representation from minorities. So from there, we get whatever data we get has very small amount of data. So there are biases creeping in, even in lexical, syntactic, or semantic or structural differences in the contents. When the data what we collect in the content, we see the biases coming in, as well as from social media. As we see, we continue those things in different connections, interactions, or activities from the networks and their attributes. So the biases start creeping in right from data when we collect the data, as well as other things. If you look at like society norms, prejudice, economic status, or there are even some seasonal activities, weekly or observed, which are observed at certain periods of time. Those data collected, they seem to have collected data which are not representative of the entire community, or they have few amount of data from the minority section. So all these things like population, behavioral, content, linking, economic or social, everywhere we see there is some kind of bias creeping in when we collect the data. And what do we do that? What is the impact of the bias? We see, if you think in terms of recommendation systems, we see that this bias reviews, customer reviews for a white person against a Black woman has created a disparate impact on the minority drivers. The minority drivers are the Black woman. It results in low wages for the Black woman. So we should be very careful that we should treat everybody fairly, and in terms of also giving recommendations like which driver you should pick up. We get alerts from Uber, right? So how do we remove bias? What are the recommendations that we have? We should be very careful that we recommend fairly to all groups of users. And for removing bias, we should concentrate on the product goals. We should identify who are the stakeholders, what are they wanting, and even if there are some of the stakeholders which has a larger say, are we fair to the minorities also? We should constantly evaluate our predictions, analyze and monitor and evaluate, and when situations come, we should look into the data where it is unfair, mitigate those, and if we are not able to mitigate, we should escalate so that the things are brought under notice of the concerned individuals who is the AI head, that this AI algorithm is not fair, and we should take actions to mitigate the risks and the biases. And what does Google's responsible AI suggest? They says involve privacy experts, involve fairness experts, user researchers, all the legal litigations, or everything you should consult before making an algorithm like a public, and that is serving millions of users from both majority and minority communities. And our goal is to include diversity, enable diversity and inclusion in diversity in terms of race, nationality, religion, social science backgrounds from different countries, as well as gender and sexual orientation. As we have discussed in the first slide, there are LGBT laws have also coming out, disability laws have come up. So we should be fair to everybody. So because we have seen that diverse inclusion enhances the performance also. So when we recommend also, we should have a diverse recommendation system that is able to include all sets of products and recommend fairly to all sets of users. So now what are the fairness common terms that we should be looking during pre-processing or during training the algorithm or during post-processing in terms of building a recommendation systems? So let's look at that. The first is the envy freeness. So that which requires that every individual should prefer their own allocation to that of everyone else. Okay, so everyone should concentrate on their own allocations, ignoring others, and irrespective of the user's qualification. And it should only stress on the user's preferences. The other thing is the individual or metric fairness, which ignores preferences and requires that similar users should be treated similarly. So this is the basic of fairness. You can find equality, odds, demographic parity, many of the definitions that I have put it into the references that arise that stresses on individual or metric for fairness. Then intercategory envy freeness, which allows users to set a set of categories that they care about and guarantee that they receive at least what they care about as any other individual. So the specific, suppose an individual who has he has preferences for jobs as well as he has preferences for getting daycare, what are the nearest daycares. So he should receive ads or recommendations related to what are the these two categories and not to something else. Whereas another individual who only cares about jobs should receive recommendations on jobs and not about daycare activities. And now we have to see that when we give recommendation to jobs to those users, they are also fair. So one is not getting too many high jobs because he has opted for jobs. That is not the case. So they are in terms of probability or in terms of like recommended a number of items, they receive fair amount of treatment. Then we also have multiple task fairness that requires individual fairness is satisfied separately and simultaneously for all categories. So individual fairness should be satisfied for all the categories that he has interest in. And as you see, there's the equation for fairness metrics, and that has to stay the same for advantage and disadvantage groups. So this is the RIG metrics, that is the d-dimensional vector represent I user, j item, and where UI and VJ are the respective user and items items involved in the matrix factorization, and we should see that the protected item rating and the unprotected item rating for any item should be same for for both the groups. We talk about the advantageous groups means the majority group, as well as the disadvantaged groups, which is the minority groups, as well as the protected. If you see this, protected user plus protected user rating plus item group should, for protected, that we term as the protected item group rating, should be equivalent. Means even if it is not equal, it's like it very close to the unprotected item group rating. Okay, so wherever we recommend anything to any user for any item, there should be same in to both the groups. And that's how there are some of the metrics that you can go through this link and read about, that how do we measure the metrics that determines that whether we have been able to achieve fairness or not. So these are absolute unfairness, underestimation. So between these two groups, is there any underestimation of fairness or overestimation, or there is any non-parity between the fairness that has been, we have thought that we have given fairness, but it is not. So we can estimate these metrics between the two groups and measure how these metrics are defined. The paper describes it, and you can measure how much fairness we are missing. And then we can use individual diversity and aggregate diversity. Aggregate diversity is like improve item diversity, so that there are different kinds of items coming from different vendors. So are we able to include all those different kinds of items and recommend it to users? And also, are we for individual diversity, are we able to do diverse recommendations to individual users? So these two are the main thing for introducing a fairness in recommendation systems. And how do we do that? We do the collaborating filtering first, and then after the ranking, we usually select top K recommendations, right? Top recommendations. Then we use ranking algorithm to take the top recommendations. Then we use a neighborhood algorithm like K nearest neighbors or any other clustering mechanisms to sample the K items uniformly. So that introduces a bit of randomness, and they try to introduce some kind of fairness. And then we use a greedy algorithm to recommend the some of these items above the threshold. So these two are kind of randomness, introducing randomness, and is designed to introduce fairness to the individuals as well as to at the item levels. And what are the limitations? That we don't have differential treatment of two users or items, and that because of that, since we don't have this treatment, the disparity among users increases with aggregate diversity. The disparity means the amount of differential recommendations, like among different users, it continues to increase with when we increase the aggregate diversity. That means when we are recommending different sets of items, the way different sets of items are being recommended to the population, to the wide variety of users, it increases. So it's good for us. So we are trying to achieve a fair system. Now look at let's multi-sided fairness. Like this, from one side you have the multi-stakeholders, different stakeholders like LinkedIn, Etsy. They are coming. Different companies are coming in LinkedIn or Etsy to sell their services. Okay, so there when we are looking at recommendations, we find mainly the reciprocal recommendations, like and within reciprocal recommendations, recommendations, the peer-to-peer recommendation, where we see that bilateral and acceptable, the recommendation items has to be acceptable to both parties. Like a job, you're searching for a job, the job who is supplying the job has to accept me, and I have to apply to the job, and I have to satisfy the criteria. Mentor or business partner. So peer-to-peer recommendations, you can see when matrimony, online dating services, sharing economy, and scientific collaboration. So when we do recommendation systems and we talk about fairness, we should, and it is multi-sided. See, from the provider side, it has to be fair, as well as from the consumer side, it has to be fair. So what we have to achieve, the objective function is like to maximize the system utility. So who is the middle one? The middle one is like LinkedIn, who is bringing together the providers and the consumers, so that their platform's objective system utility or the objective function has to be maximized. And the same goes on. How do we do that? We use a user-based neighborhood algorithm. which uses a regularized based sparse linear method with neighborhood balance. So in the first one, you see it is unbalanced because we don't apply regularization, we don't have regularization coefficient user item pair, we don't minimize the regularized loss function, whereas here we have a weighted system of including the regularized coefficients. If you want to go, you can go into the details of that. I don't explain here because of the limited time. So we have a balanced method of including the regularized coefficients, so that it is fair in terms of user-based neighborhoods. Okay, so same thing, the provider fairness increases market diversity and avoids monopoly. Like one provider should not demand control the market, so rather than to give other providers a fair chance. Similarly, consumer fairness, it will help in personalization as well as on protected classes, the protected classes, that minority consumers will get an appropriate, fair, recommended items. And with that said, we continue with the item-based balanced neighborhood. The left-hand side shows user-based filtering. The right-hand shows item-based filtering. If you're not aware of, you should read into collaborative filtering, user, and user item recommendation. And what we try to do is we try to expose users different kinds of known services or different kinds of services available from different geographical regions, and we balance between protected and non-protected users, as well as we balance between protected and non-protected item groups. So some of the new items which are introduced into the market, that should also get a fair chance of getting recommended to users. With having said that, there is we use the maximum share for producers and envy-free up to 1 fairness for every consumer. So maximum share for producers and envy-free up 1 fairness for every consumer. And if you see, it is nothing but considering the product relevance, the product exposure, the consumer choice, and this is maximizing the utility function. So these are some of the data sets, and I have mentioned the code which I have used in Run. It's there in GitHub. It's comes from a paper, so you can go through that. And how we do that cardinality, the constraint-based allocation for fair recommendations system, it is called cardinality constraint fair allocation, where all items are grouped into disjoint categories and no agent receives more than a pre-specified number of items from the same category. That means all items fall into some groups and no individual receives more than a X value of any specified groups. And it is extended that there is a specific K item that is allocated to each customer. First we apply this, and then we determine the K, which is the number of items of specific category that can be allocated to each customer. What are the advantages? If you do like that, you include that in the advantages can be seen in economic, social, judicial use cases in the society. Everywhere you see that fair recommendation systems have been very useful, and it is a long-term goal. It is a long-term sustainable goal to ensure a fair system. And you see that there will be a chain of systems. First, you have to find out whether the user will click an item. Then you will find out that the user will click 5 or 4. So there you have to build a chain of recommendation systems. And how do we do that? We'll see through use of compositional fairness. And these are some of the metrics that you can use to measure whether the system is fair or not. The fraction of satisfied producers, inequality of product exposures. Is there any product group that is getting exposed more than the other? Then exposure on loss on producers. Then the enviness. These are for, last 2 are for user metrics. The first 3 are from the provider metrics. So mean, average, envy. Is there any envy between different users? One is getting more than the other. Okay, and then the loss and disparity in customer utilities, how it is helping the customers. And then if you compare this, you will see on the intra-group, means within group, and intergroup within the other group. So what is the difference? So there is pairwise comparison between different groups. And you see when we do intra-group or intergroup, when we do the pairwise comparisons, the right-hand side figures are much more closer than the left-hand side. There's much disparity on the left-hand side. So how do we do that? Because we have to say that how good is the recommendation system. So this pairwise regularization technique has been used to optimize the intergroup and intergroup fairness. And this is how the performance looks like. Having said that, we should build an end-to-end fair systems with high platform utility, where we should build not only one systems when we are doing a chain of recommendations from user clicks to the comes to the point when he is rating 4 or 5. So first here we have to determine that is the click is fair, then we have to determine whether the his rating 4 or 5, that is also fair. So it's a chain of recommendations, and there comes the compositional fairness, where combination of intercategory NV fairness and total variation fairness within is within each category, and intercategory means within different categories. Everything has to be fair. We try to combine this and try to design a system with high platform utility. And this is the conclusion. That's how fairness doesn't come in without any trade-off. So your accuracy will get a hit. So fairness and accuracy, you have to determine the right trade-off and utilize fairness. And these are some of this, like we should ensure that we are able to handle sparse data and bias from different advertisers. We are able to determine the right personalization. What is the key outcome? Is it salary or is it job? What is the key thing that the users are looking at? Are we able to arrive there? Are we able to handle the harms, misbehaviors of anybody who, like the providers who are coming into the systems? How do we develop computationally very fast systems for multi-stakeholder fairness optimization? Because fairness optimization may involve multiple constraints. We have seen few constraints, and the network structures, the relationships between providers, users, adding time-dependent constraints, and the equality treatment versus equal outcome. That is our major objective. I'll be able to do that. So that will help us to bring a fair system. So that's how I end today's talk. Any questions, just reach me out, or we can ask in the comment section. These are the references, and this is the code. I have put it in the references, so you can go ahead and run this code. This code runs, and the reference is there. So I don't want to take time. It will run, and you will get the required output. Okay. Thank you.
Thank you so much, ma'am. That was wonderful.
Yeah, thank you.
Thank you. Thank you so much. So up next, we've got our next speaker, Ms. Maithili Krishnan, and she's the Vice President, Analytics and Data Science at Accenture. And today she's going to be talking about failure prediction for server and web applications using anomaly detection.
Maithili Krishnan, and today I will talk to you about application failure prediction with anomaly detection. So this is the agenda for today. Quick brief about me, then the business case that we are going to discuss today. What is application of server failure? The use case for today, a little brief about decision trees. Then we will discuss in details about isolation forest, because that is the algorithm that we are going to use today. Then there will be a short code demo and then further references. So let's get started. So I am a vice president with diverse industry experience in analytics and data science solutions and client consulting across the globe in domains like financial services, large platform clients, telecom, infrastructure services, and customer analytics. I'm also the winner of 3 AI Pinnacle Awards 2020 in the Women in Analytics and AI category. I'm also an inventor of 4+ patents and author of various research papers in the areas of machine learning and data science. Here is the link to the deck that I'm presenting today, and also link to the demo code if you want to refer to it. So with this, let's get started. So have you ever encountered these errors where maybe a page is not working or a service is not available, 503 error, 404 error, while trying to browse the internet or maybe launching an application? I'm sure you have. So many of us might have encountered some of these errors in our day-to-day life while working on applications or even browsing some sites. So how does it affect us, or businesses in general. So with this, we will move to today's topic, and I will kind of like give you the business context. Failure or performance degradation of servers and its associated applications has been plaguing all industries since long. Typically, there are monitoring systems in data centers that monitor the health of these applications, some of which are extremely critical for successful running of business operations. Failure to do so can result in huge financial losses as well as productivity of customers or users. Hence, proactive and early detection of such failures can help prevent such financial and productivity loss. So now, what do you think is an application or a server failure? It can actually range to quite a different set of things, from hardware or software outages to network issues, excess memory consumption due to concurrent processes, or it can simply be human coding errors in applications. All these can cause an application to fail or stop running. And what are the industries or possible domains that can be affected? So it can range from financial services, healthcare, e-commerce, to even manufacturing. So today we will talk about a use case in e-commerce. All of us might be using different e-commerce websites to purchase different products. Now, behind this are a lot of applications and servers. Like in this case, when a user sends a request inquiring about the price of a product, or he wants to check out and buy the product, the response is sent to van search and then through a firewall, which is connected to load balancers, to different web servers and e-commerce nodes. This in turn connects to a database which houses all the product information. The query then looks up the relevant details in the database and sends the response back to the user. In this process, if anything breaks in between, like the e-commerce node fails or the web server fails, the user or customer will not get the response. So you can imagine this means that there could be one less product that was purchased for the merchant. In the following slides, we will talk about how we can predict failure of such an e-commerce website using techniques like anomaly detection. Now, just to brief about anomaly detection, in a 2D space, let's say we have two features, x1 and x2, and we plot these instances. As you can see, there are two clusters that exhibit normal behavior, while these red dots, these are further away from the clusters, are the anomalies. The anomalous behavior can be a function of density or distance or even context of a business problem. In our e-commerce example, let's look at one feature, that is traffic of the web server, that is how many users are sending requests to the server at a daily basis. In this case, logically, we can conclude that the two red circles on day 21 and 25 are probably an aberration, because in these days, the number of requests far exceeds the normal server traffic. And this might be the reason for the server to fail, because the application might not be able to handle so many concurrent requests. Hence, detecting the anomalies in the data can provide us the direction towards detecting failure. So, what types of data can then be used for solving this e-commerce use case? We already talked about one feature in the previous slide. Now let's look at other features. Here we have to create the features from the log data of the application. Because the application is connected to servers, we also have to consider all the related server data. To simplify, we can consider web server access logs, which is a list of all individual files that a customer has requested from the website. And from here, we can create features like IP addresses, daily server traffic, response time, etc. Similarly, error logs can provide details on type, frequency of errors. and also severity of errors. Thread count is the number of individual application threads in sync with the user's request. We will come to this data and we'll see how we can use it a bit later. Let's now do a quick refresh about decision trees. So here on this slide, you can see two decision trees. Now, how does decision tree algorithm work? It works by starting with a root node from a data sample and then select features based on metrics like Gini impurity or information gain and split the root nodes into leaf nodes or end nodes till no more split is possible. It is possible to detect anomaly using decision trees because it isolates the outliers by randomly selecting a feature from the given set of features and then randomly selecting a split value between the max and min values of that particular feature. This random partitioning of features will produce shorter paths in trees for the anomalous data points, thus distinguishing them from the rest of the data. Like in these figures, the red rectangles are the anomalous data points, and we can see the path traversed given by the red lines as the shortest one. Now let's go to our isolation forest algorithm. So this is an unsupervised learning algorithm that identifies anomaly by isolating outliers in the data. Usually, first step to anomaly detection is to construct a profile of what is normal and then report anything that cannot be considered normal as anomalous or as an aberration. However, isolation forest does not work on this principle. It does not first define normal behavior and it does not calculate point-based distances. Isolation forest instead works by isolating anomalies explicitly and by isolating the anomalous points in the data set. It is based on the principle that anomalies are observations that are few and different, which should make them easier to identify. It uses an ensemble of isolation trees for the given data points to isolate anomalies. Isolation forest recursively generates partitions on the data set by randomly selecting a feature and then randomly selecting a split value for the feature. Presumably, the anomalies need fewer random partitions to be isolated compared to the normal points in the data set. So the anomalous points, as shown in the earlier slide, will have smaller path length in the tree, path length being the number of edges traversed from the root node. Using isolation forest, we can detect not only anomalies faster, but also it requires less memory compared to other algorithms. Isolation forest also isolates the anomalies in the data points instead of profiling the normal data points, as mentioned earlier. And since the anomalous data points also has a lot shorter tree paths than the normal data points, so the trees in isolation forest does not need to have large depth. So a smaller max depth can be used, resulting in low memory requirement. And this algorithm works well with small data sets as well. The usual methods are not optimized to detect anomalies. Instead, they are optimized to find normal instances, because of which the result of anomaly detection either contains too many false positives or might detect too few anomalies. Many of these methods are also computationally complex and hence suit low-dimensional or small-size data. Now, for the sake of completeness, I will just show you the formula for anomaly score. This is the mathematical formulation. I will not go into the details of this, but the point to remember here is closer the score is to 1, higher is the likelihood of the instance being an anomaly. Now I will give a short code demo, and this will be based on one feature, the traffic of users, and I will explain how this concept can be used to finally do the failure prediction. So let's look at the data set first. So this is a data set which has different features like traffic of web server, which we talked about earlier, daily error type, a daily request count, average response time, and it also has a target here. We will consider this column A for our purpose today. Now let's go to our Python code. So first, what we'll do is import all the libraries, that is NumPy, Pandas, the matplotlib, and also the isolation forest module from scikit-learn. Then we have to import the data set. And since we are only considering traffic of users in the web server, so we'll isolate that as an independent variable and call it X. Now we will build the isolation forest model to detect the anomalies. And here, since we only have one feature, so we are just using the default model without any changes in the parameters. After the model has been fed to the data, we compute the anomaly score. And as you can see here, so these are the anomaly scores. And it also has created 1 and -1 as those which are detected as anomalies. One point to note here is in scikit-learn, the anomaly score works opposite of what I had just described. And here, the lower is the score, more closer it is to being an anomaly. So you can see here, this particular observation is an anomaly. And this is probably a false positive, which could not be detected. And we'll see why this has happened. So now we have to evaluate the model. So let's define our outlier with a threshold of greater than equal to 5 and the outlier counter. So if I count in the data, it comes to around 7. So we should actually be detecting 7 outliers. Let's visualize the anomalies. So this is a code you can use to visualize it. And you can see the region which is greater than equal to 5 is actually defined as the outlier region. Now, this is a step that we can do just for illustration purpose because we have predefined targets here, and we'll look at the confusion metrics to understand like how good our model has performed. So we define by underscore target as the target variable, and this we will compare against our anomaly which was generated. So as you can see here, the model was able to capture 5 of the anomalies perfectly. It could not capture 2 anomalies, and 1 was a false positive. So probably because it was like more closer to the threshold as we saw in our data set, which is almost like closer to 5. So we have a pretty good accuracy of about 95%. Let's go back to our slide now. And now that we know how we can detect anomalies using one feature, we can extend this to consider multiple features as well. The approach we can use is as follows. Once we collect the log messages from different log files as described earlier, we will need to parse this to create a structured data set similar to the one shown in the code along with timestamps. Then we can use association models like a priori algorithm to create patterns between the errors and other features. For example, let's consider 4 errors for sake of simplification, 1, 2, 3, and 4, with 1, 2 coming from the web server logs and 3, 4 coming from the e-commerce server nodes. Now, the individual errors 1 or 2 can cause the application to fail, or a combination like 2, 3, 4 and 1, 2 can also be a pattern that can generate failure. We store all these patterns or features in a pattern dictionary and use these features to generate the anomaly scores. So failure type A, see a network issue might be caused by a pattern 2, 3, 4 in combination with 1, 2, while failure type B might be caused by a pattern with features 2, 3, 4 only. So using these principles, we can conduct failure prediction for any application and thus create proactive alerts that can prevent the failures from happening. These are some references that might come in handy. And this is how you can reach me. This is my LinkedIn profile and my Twitter handle. And with this, we come to the end of my session today. Hope you enjoyed it and enjoy the rest of the sessions. And do reach out to me in case you have any questions.
Thank you so much, ma'am. That was awesome. And let's move on to our next speaker. That is Miss Ruhi Sharma Mittal. She is a research software engineer in IBM India. And today she's going to be talking about data quality for machine learning.
Hello everyone. First of all, I would like to thank Usha and her team to give me this wonderful opportunity. I am Ruhi Sharma Mittal. I graduated from IIT Bombay in 2015 and since then I am working as a research scientist in IBM Research Lab, Bengaluru. So today I am going to talk on a topic overview and importance of data quality for machine learning tasks. So let's get started. You must have seen articles like this, which have said that data preparation accounts for almost 80% of the time in ML pipeline, and it is the most time consuming process in our data science life cycle. Therefore, to start with this work, the question we asked ourselves was the following. Why is data preparation the most challenging activity in our data science life cycle? Why it account for this much of the time for this full cycle? So once we understand why this challenges happens, then we can do something to try to optimize this. Now, if we see, this is what a typical data science life cycle looks like. So a data scientist gets some data or gather some data, do analysis on it, do cleaning on top of it, do some transformation, feature engineering, build a model. And once we have the model and results, communicate it back to a user. So this is actually a typical life cycle, but we think that this is actually a practical life cycle too? I think the answer is no. In practice, the cycle looks something like on the right side of us. We take data as a data scientist, we analyze it, do cleaning, do feature engineering, and build a model. And then a surprise. Oh, our model is not performing as expected, which means there is some issue for doing all the process before this step, which means, oh, have I missed something in doing good feature engineering? Or I don't have particular data for this particular task. Do I need to gather more data? So all these questions actually arise once we get to up to the model state and don't get as expected the performance. Therefore, in practice, a data science life cycle is really an iterative debugging rather than a sequential step, which makes it a cumbersome and a time consuming task. Then, now a question to ask here is why it is an iterative process? Why can't we have it as a sequential thing? Why it is far away from the ideal pipeline? And one of the reason for that is before even going up to the model, do we know what challenges my data actually exist? Do we beforehand know, okay, my data has this issue? Or up to the feature engineering step, do I know, okay, my data has something so that I need to do this feature engineering in this way rather than this way? Or okay, my data is of this type, so I have to build model, or while selecting a model I have to take a choice of this model on top of this model. This is what precisely you know made us think and drive our energy at the point towards the need of data quality measurement for data science life cycle. Therefore, here we can very clearly understand we are right now in practice are far away from the ideal pipeline. Now, uh, as a data scientist, what could happen if we know, okay, beforehand that something is there in my data, or we know clearly little bit picture about the data. So knowing all these issue actually will help us in building a better model. Why? Because at each step of the pipeline, I can take an informed decision. Okay, my data has this issue, so I will do this kind of feature modeling, or I can choose this kind of models, which in turn actually help us to reduce the time for doing all these projects. Which means once we answer all this, then we are trying to move from the right hand side where the this pipeline is actually a iterative debugging to a sequential thing. We are not sure whether we can reach this ideal cycle, which means whether it could be only just one sequence and we will get one. But rather than doing that, rather than having this much iteration, can we use iterations to some instance? For example, let's say again and again I'm building model doing something, and then again I'm going back to my gathering stage, analysis stage, and or data cleaning stage and getting okay, this is not. Can we, like, if I'm doing that for let's say 10 number of times, can I reduce it to 2 or 3? So that's what actually we at IBM Research Lab trying to do. Can we have some framework which before even entering this life cycle tell us okay what quality of data I have in hand, what issues this data has, so that the data scientist can take informed decision. So till this point, we know okay how a data scientist could use this pipeline for its benefit, like the pipeline where this data quality is also there. For an example, okay, let's take an example from the data scientist point of view only. Before starting this pipeline or before starting doing any transformation in feature engineering, if as a data scientist I know okay the data set which I have in hand is let's say a binary classification problem where I have a class A and class B. Uh, now I have let's say a quality metric black box which will tell me okay your data has 30% overlap in it, which means right now whatever features my data has, those are weak features. That's why I can see a overlapping between my classes. Then using this information as a data scientist, I can take an informed decision at the step of the feature engineering. I know okay the features which currently data has are weak features, so I need to build more better features there. Or during selection of my model, I can select models which actually handles overlap very well. So that's how, as a data scientist, I can take a decision. However, in enterprise setting, along with data scientists, there are different personas which come together, collaborate together to build an effective model to the production level. For example, data steward, business users, business matter experts also. To give you an example here, for example, let's say as a data scientist, I got some data and I know, okay, using some quality metric, I get to know, okay, my data has label noise. But I'm not a subject matter expert. I can just say, okay, this pattern, this type of pattern is there, and the label of that data is labeled as label 1. However, that's not correct. It's not like correct according to me. But what could be the label be? I am not an expert of that. Then, as a data scientist, you go to subject matter expert and ask them their opinion. Okay, this is what I found in the data. Do you agree that rather than having it as a label 1, it is more appropriate to have it as a label 2? And if they say yes, then we change the full those patterns from label 1 to label. That's why in an enterprise setting, all these stewards, all these personas come together to build a proper model, and all these personas are actually also important in analyzing the data quality. So to put all together, uh, we need actually algorithms that can assess training data set to improve our turnaround time for data science projects, as well as to build effective models. Then these algorithms, the necessity is it should work across modalities, because the data right now these days we have comes from different modalities. It could be structured, unstructured, time series. So that algorithm should work towards to across different modalities. Along with that, since we know in enterprise setting all these truths come together, then there is a need of a framework in which these different personas can come together and interact with themselves. Therefore, with all these need, we need for automation. Now, to summarize, I would say, okay, we have seen that there is actually a need to do data quality before entering into data science life cycle. And we already know there in the last few years, there are already have like most of the work has done in doing automated machine learning, which means to improving the machine learning algorithms. But machine learning algorithms can perform up to certain level, and their actually performance is directly proportional to the quality of the data which we are feeding into. As a famous quote is there, garbage in and garbage out. So if to your best of the model you are not giving good data, the performance could reach up to the certain level only. Now, to further improve your performance, you require a better data to be provided to your ML model, which means then there is actually a need to systematically study the quality of the data with respect to machine learning task. So here is a list on data quality metrics. In the interest of time, let's discuss one of the metric called data valuation. So data valuation is actually a task of assigning a data value point to each sample based on its impact on predictor's performance. So here we can see we have a, let's say we have a training data, we give it to prediction model and we get some output. Along with that, we let's say we have a valuation model. So valuation model also require training data and validation data as a input, and towards the end it assigns actually value to each datum, saying whether that particular data point is useful or not useful for that particular prediction task. So in this example we can see, okay, in our validation data we have only images of cat and dogs, whereas in our training samples we have images of horses also. So if my task is detecting cat versus dog, then this horse images will be low valued for me. So this data valuation will assign a value of low to my horses images, whereas high value to my cat and dog images. Now we know, okay, the horses were given a less value. Now, do we think all the cat images actually should be given the equal values? No, because using one cat image versus using another, since the prediction or the performance of classifier is not equal, then the values which we should assign to these individual data points shouldn't be equal, which means then there is a scope of providing data value to each point, which will actually be a proof or a indicator of how well that particular data point is helping in our prediction. So scenarios in which actually data can have low values. For example, if let's say I have incorrect label, then that particular data should have less value. If let's say my data has some noise, then noisy data point should have less value. If my data point is not at all useful for my target task, then the data point should have less value. So where things could be used. So first, once we know, okay, how is my quality of my data at each individual data point level, then I can take only the high value data point which are very significantly contributing to my data set classifier performance, and I can drop some noisy points, and noisy points have we can detect from low value data points. Now it can help in domain adaptation also. For example, if let's say I have data for one particular classification task, then knowing whether if I have another task also in my hand, knowing whether that data which was meant for performing well on classification task 1 will perform better on this also. And it will help in data gathering process also, because once we know okay which type of data is actually valuable to me, I will go and collect that type of data only. So the strategies to do this is, first strategy is leave one out, in which actually to provide a data value or a value valuation point of a sample, what we do is we calculate the performance of learning algorithm on full training set, including that particular data point, and then we subtract it from a performance of learning algorithm after excluding this data point, which means after excluding this data point, if let's say my performance increased or if my performance remains same, which means then this data value or this data sample should be given less value. But after removing let's say my data point, my performance decrease, which means this data point is very much important for my classification task and it should be given high value. So here is one example of it. So how we calculate, we take full training data and we remove that particular data point, and whatever performance difference we get, we assign that value to the as a value of that particular data sample. Now, one problem this approach is having, it doesn't actually captures the interaction between the data. For example, here we can see for each data sample, let's say if I have exactly similar duplicate sample in my training set. So using leave one out, we will get all values of 0 here. But do you think it's reasonable? No, because see, though there are duplications in the data training data, but individually they all are contributing something to the classification task, so all shouldn't be given value 0. So to actually overcome this, then there is one more data valuation algorithm which is known as data shapely. What it does, it actually captures the interaction between the data points. So what it do is it actually calculates all the subsets, available subsets in the data, and then reiterate over it, and then finally calculates the value of a data point. So for example, here we can see it iterates over all subset, then it find out okay what is the performance using a particular data point in all the subset of data minus removing that particular data point from all the subsets. Then what we get, that is assigned as a Shapley value of that particular data point I, which means this consider every, like since this is considering all subset, it consider all possibility of uh, impact of that particular data point and assigns a value. So just one problem with this thing is, since we require it to iterate over all the subset of data, and these days we work with big data with millions or billions of rows, this is not practical enough to use because it has computational complexity. There are some approximations to do it, but with the approximations also, it is very hard to use in a practical scenarios. So to overcome this, recently there is one more approach came, which is DVRL, data validation using reinforcement learning. What it does is, along with learning your classifier, you learn a model which actually provides data value to your data samples. What you the concept of it is, like there is one module which actually calculates how much impact this data sample is doing for for your prediction performance, and using that the reward signal is going to this data valuation estimator. So data valuation estimator is actually assigning value to each data point, whether that like is a high valued point or a low valued point. Now, using this loss function, we calculate the reward, and that is given as a signal to this data value estimator. So using this, since this is done along with the training of a model, and so this is computationally effective. As well as here we can see in the results, when we remove low value data points, this blue lines, okay, the performance improves. Whereas if we remove high value points, which means these orange graph, so the value or the performance decreases, which means the values assigned by this algorithm or framework is actually working in practice. So in summary, we have seen why actually this data quality should be addressed before doing any ML pipeline. We have seen examples how it could be useful for data scientists as well as for other personas. Then we have seen few examples of uh, some data quality metrics which we can use, and we have seen, okay, various personas come together to do this. That's why there is a need to perform to do a framework which can actually help in data quality assessment using all personas in enterprise setting. So that's all from my side. So I invite you to join us on our agenda towards a data centric approach to analyze data quality. Please feel free to contact me for your ideas and inquiries. I would be happy to answer all of those. Thank you.
Thank you so much, ma'am. That was amazing. And we've got our next speaker lined up. That is Miss Aarti Kumar. She works as a data scientist at Alliance Belgium. And today she is here with us and she's going to be talking about data science in the accounting world. Over to you, ma'am.
Thank you, Shashank. Am I audible?
Yes, ma'am, you're audible.
Perfect. Good noon, everyone. I'm Aarti, and yeah, I'm going to be talking about the application of data science in the accounting field. I'm a professional accountant turned data scientist, and in the last 10 years, I have worked in the intersection of accounting and data science. Let's first look at what a typical profile of an accounting or finance professional is. Yeah, it requires a rigorous qualification, and it is a complex knowledge and a skill base to become an accountant. And accountants play more of a behind the scene and a support function role than in the front end. And there is a large supply of labor in terms of just chartered accountants, commerce graduates, and interns, and etc. Let us focus more on what do they do and the concerns of today, right? Like today the problem is the talent supply is dwindling. People hate more and more manual labors. People want to do a lot more intellectual stuff. So the data entry job and the manual job that the accountants were doing are not interesting anymore. There is an issue with the consistency of output in the sense that it is a manual job and it is very difficult to ensure that the output is consistent from all the human beings. There is a seasonality stress. For example, when there is a book closing or tax filing dates, there is a high stress around the work and the need. And then there is a non-peak season where there is low work, and then it requires super specialization in terms like a lawyer or a doctor. There are areas where it has to be a case to case basis decision and not a uniform decision. And then accountants are also a midstream. For example, a lot of their work depends on what comes before in the company and what comes after. Before in terms of data capture and availability of good data and things like that, and what comes after is important financial decisions. Where do they operate? They work in the accounting entry area, or ARAP processing, accounts receivable or accounts payable, reporting, a lot of management reporting, audit and risk, finance operations, and professional advisory services in terms of audit or tax preparations or compliance. What is their existing technology exposure as of today? They are mostly exposed to ERPs, as a user of ERP and Excel, this is pretty much like the majority of the accountants. And then some of them go into ERP and RPA implementation, work on advanced Excel macros and dashboards, and then tech implementer in terms of working as a consultant for any of these ERP, BI, or RPA implementation. And very few of them today work in the modeling and cloud computing sector. But there is a lot more demand in the AI space for accountants. Sorry, there is a lot more demand for AI people in accounting world. So what is the purpose of accounting? Right? Accountants want to help organization and economies work better by giving good advice and making good decisions. Accounting is not an end in itself; it's means to an end, and all the activities associated with the accounting ultimately aim to help people make good decisions about the allocation of resource and hold others to account for their decisions. So, for example, when should a company raise fund? If they have raised funds, where do they allocate it? Should they buy something or rent something? All these comes from accountants' perspective, and they enable the CFOs to make the right decision. So this helps in underpinning the investment growth and confidence in the companies as well as the economies. 6 key activities accountants perform. So right from the data capture, like data entry, like from the billing side, and then data generation, they collate all this information. They need to record it in the double entry bookkeeping as per the rules, and then transform the data into a final profit and loss statement or a balance sheet so that you can understand the performance of a company. They work in the risk audit and taxation, so they review the company from a risk perspective, financial audit, statutory audit perspective, and then taxation perspective. They work on reconciliation, so there are like 2 books that are maintained in the company, usually for the tax purpose and for the financial accounting. So there is a lot of reconciliation work going there. And then judgment. So there are business rules, there are laws, and then there are case laws. So there are like some rulings that forms a rule for the future, and the accountants needs to be able to understand and apply these rules and laws on the transactions and during the life of the company. And finally, reporting. Yeah, they work on reporting the financial status of a company to the management as well as the key stakeholders. How can AI help with accounting? AI can help in capturing and recording cheaper data. For example, OCR instead of manual data entry, generating new insights from the analysis of data, right, from auto generation of dashboards from the data to modeling, AI modeling as well. And AI can help the accountants in freeing up their time so that instead of working on menial and manual task that just consumes energy, they can focus more and more on the intellectual task where it requires a lot more human judgment. So yeah, this is one of my favorite quotes. Over the next decade, AI won't replace accountants, but accountants who use AI will replace those accountants who do not use AI. Right? AI is a tool, and it only becomes better based on like where you use it. This is a McKinsey report that shows the maturity and adoption of AI in each industry. I'm sorry for the small font size, but I will read it out for better understanding. So here you see the industries, and here you have the overall AI index on the adaptability and influence of AI in the industries. So the darker the color, the higher the influences, and either in the data assets or in the usage or in the labor, like how it is today for these industries. And if you look at it, professional services has very little intervention today, but it means that there is a lot more scope for the future. So as per the McKinsey report, AI can automate nearly 86% of the activities performed by bookkeepers, accountants, and auditing clerks. And this also comes to the fact that what are all the top emerging jobs and top declining jobs. And if you look at it, accounting, bookkeeping, and payroll is in the top 10 declining job as per the World Economic Forum report that was released in 2018. The leading firms have already started their AI investments, right? Like the big four accounting firms like EY, KPMG, Thomson Reuters, like Avalara, and there are a lot more firms that are on the accounting software side or on the audit side. They have started their AI investments. And EY recently announced to invest 1 billion in new technology solutions, which is a part of an ongoing strategy. And then KPMG also made sure that like 5,000 startups worldwide would be recognized in creating new solution for their clients. And Thomson Reuters has formed a strategic partnership to expand the data ingestion and analytics capabilities. So these are all just examples, and a lot more are happening in this space. So the market is changing, and the businesses worldwide are experiencing data disruption. More than 90% of the data is generated in the last 5 years. This you would have heard everywhere, right? This is true for accounting world as well. And accounting is one of the area where it has no data science disruption so far, but doesn't mean that it is going to be stagnating, and there is a lot more scope there. And some of the industry use cases from PwC. So what they are doing is they are redeveloping existing services, for example using simulation technology to help understand the effect of certain efficiency measures within companies. This means creating models that build and test digital twins of processes to make them more efficient. Another example in data assurance is that machine learning can be used to assess the quality of regulatory regulatory needs and identify anomalies. And yeah, back office support, using AI tools to improve accuracy for efficiency. For example, optimization algorithms can be used to analyze resourcing and to match staff to jobs more effectively in audit work. For technical services, AI can also be applied to answer questions about international financial reporting standards, IFRS. Deployment of AI for clients in consulting. So these includes multiple use cases depending on the industry in question. In business to consumer industry, such uses would be including AI-based customer profiling, identifying demand trends and forecasting sales. Brand new product offerings include the analysis of biometric data using AI to help employees manage their wellness and work efficiency. So Goldman Sachs is automating the IPO process. It cuts existing 127 processes by half. So yeah, Linklaters is using AI to reduce document review time and bring more than 40% efficiency. Some of the industry landscapes, so there is accounting software like Tally, QuickBooks. So Intuit is recruiting a lot of AI and data science professional to be able to add features in their product. And then existing companies work either in the big fours or large companies. They use data science teams to look at how better they can offer their services. They can differentiate their services. There are startups which are providing software as a service, either for auditors in terms of review or in terms of process automation for RPA, like Wik.ai, Smack.io, and then Prudent.ai, MindBridge. These companies are working on supporting the auditors in their work. Why is this change imminent now? On one side, the accounting tech landscape is changing. So there is a lot of intervention in terms of the traditional accounting softwares like Tally and QuickBooks, BI, CRM. These are just an example, and the technology is improving and in turn the accountants have to improve as well. So these are some of the example of like where the subscription management and the business funding, everything is getting digital, and the data capture is much more better in this. So, and then the economy and the business models is also changing, right? Like, so we have new sharing economy. There is, Amazon and Flipkart having marketplace. There is a new business model. Oyo and Tribo, instead of building inventory, building assets, they are into, renting it. So these are also forcing the accountants to like change on how they evolve along with the new market needs and business models. What is the way forward for accountants, right? Like this is like a famous Charles Darwin quotes: it is not the strongest of the species that survives, nor the most intelligent, it is the one that most adaptable to change. We always worry about scenarios of accountants losing jobs, but the same fear we had when we had computers like 30 years ago, right? AI is a tool, and the key is in how the person holding the tool uses it. AI will not replace accountants, and it is better to learn to adapt than to resist. What does being adaptable means to accountants? When business needs change and all the relevant stakeholders agree, the profession can adapt. Professional bodies change their qualification as market demands evolve. So the Chartered Accountant Institutes are making sure that that data science and analytics become a part of their curriculum. Accountancy organization and business and practice innovate all the time to provide more value. This quality will become increasingly important for all stakeholders involved in this profession. What should accountants do to write this way with ease, right? Organization will also need access to right skills. Clearly, this starts with technical expertise in machine learning, but as with data analytics, these skills need to be complemented by deep understanding of the business context that surrounds the data and the insight required. Accounting roles are already changing in response to new capabilities in data analytics. Indeed, accountants are well placed to work effectively with data analytics as they combine high level of numeracy with strong business awareness. These trends will accelerate with AI. Some roles will continue to emphasize technical accounting expertise and human judgment to deal with difficult and novel cases. Other roles may expand to increase collaboration and partnering with other parts of organization to help them drive the right meaning from data and models. There will also be new jobs. For example, accountants will need to be involved in training or testing models or auditing algorithms. They may need to get involved in projects to help frame the problems and integrate results into business processes. Other accountants may be more directly involved in managing the inputs or outputs, such as exception handling or preparing data. This evolution will be re-emphasized in skills required of accountants. Some roles such as training models may require deep knowledge of machine learning techniques. In other areas, accountants may just need a more superficial knowledge of machine learning to be able to have informed conversations with experts and other parts of the business. Critical thinking and communication skills are likely to become increasingly important. In addition to skills, accountants may need to adopt new ways of thinking and acting in order to make the most of machine learning tools. For example, spending more time on predictive and proactive activity, like putting predictions in context or building capabilities to change course quickly, will need different ways of thinking. So yeah, so what is that accountants need? Like they need to go beyond Microsoft Excel, so they need to get used to using larger volumes of data and learn model tools, learn to use approximation. So instead of being absolute, either black and white decision, they need to be able to understand how probability works and how confident interval works. They need to go deeper on their own specialist area, like more and more understanding how the laws are changing, how the case laws are changing, and keep them aware of the latest in their own field. Focus on domain knowledge, either industry specific or business specific. So business specific, like being updated on new business models like sharing economy, and understanding how pricing works, how Oyo prices their rooms, or how Amazon offers discount using machine learning. And they also need to understand the limitations of AI. So what is the bias and error rate, and how it affects the decision making, and how they need to be able to take informed decisions and work along with the AI and not against AI. Thank you. That's the end of my talk. And I would like to thank WiDS Mysuru for giving me this opportunity.
Thank you so much, ma'am. That was a wonderful session. It was very enlightening. And we've also got our next speaker lined up. That is Professor Manjeera Sinha of IIT Kharagpur. And today she's here with us and she's going to be talking about advancements in NLP research. Over to you, ma'am.
Hi everyone, good afternoon. Am I audible?
Yes, ma'am, you're audible.
Okay, just let me share my screen.
Yes, ma'am.
Okay, so is my screen visible to all?
Yes, ma'am, the screen is visible.
Okay, so today actually I have picked up a specific topic in advancement in NLP. I will go into that. But first, a little bit about me. So, my name is Manjeera Sinha, as already announced. I am actually assistant professor in Center for Educational Technology at IIT Kharagpur. My research interests are mainly in the natural language processing, text mining, because primarily I am a computer science engineer, and also I work in language comprehension and assistive technology. So language comprehension means that how do we understand language and computationally simulating that, and assistive technologies are the technology for the persons with disabilities. And also I work in computer assisted education, that how computers can play a role, how technology can play a role to make education accessible and affordable to all, say our marginalized and underprivileged section of the society, and also in local languages. So you can reach me for any queries at my mail ID. It is manjeeras@gmail.com. So before beginning my talk, I want to thank WiDS Mysuru and Usha for the opportunity, and also all the young volunteers and the anchors for coordinating the entire event. And I just saw that the previous talks were really amazing. So I am just hoping that I will be match up to that standard. So today I am going to talk about one specific problem that I have worked in, because it's NLP is such a big and vast and very diverse domain. So I have decided to focus on a particular work. So this work is titled as Relation Aware Attention Model for Uncertainty Detection in Text. So although the title seems a bit complicated, but don't worry, we will walk through it. And my apologies for the slideshow malfunctioning. This is actually a joint work with Tirthankar Dasgupta from TCS Research and Innovation Labs, and with Nilesh Agarwal, who is a UG student at IIIT Guwahati. And this paper is actually published at the ACM IEEE Joint Conferences on Digital Library, that is JCDL, in 2020, and the DOI is also provided. So you can uh, go to the link and can actually look up to the paper if you have any if you want to know more about the technical details. So, as the title said, it is uncertainty detection in text. So, what is uncertainty? It is uncertainty in a text refers to the proposition that exhibit fuzziness in meaning and whose truth value cannot be determined due to the lack of information. We will see some examples later on. So, for the past few decades, uncertainty or vagueness has been a subject of vigorous debates in the philosophy of logic and language. So, what is to be called uncertain and how they can be captured, and particularly in the field of computational linguistics or natural language processing, it is important because we are now working with large volume of various data sets, and it is all user generated data set. So it will be imperative that they will contain lots of fuzzy words or uncertain terms. Say for example, this sentence. Many students are against the university decision. When we say many students, it may denote 50 or 60% of the class. That is the majority of the class. But say if in Amazon shopping we come across a description as many of our prime customers have shown interest in the product. So in this case, this many may refer to 5% of the customer base, but it will still be a significant value to be called as many. The reason being it is a very different context than a university decision. So depending upon the context, a lexical cue may or may not be treated as uncertain. So now we can understand why this task is not trivial, because it is not dependent on a particular term. It is dependent on the context at which this term is spoken about. Say for example this sentence, that there is a rule of thumb that whenever we use the term like probably or maybe, we term them as the uncertain terms. But in case of scientific documents, say if I have a sentence like this, the gas leakage probably causes the fire accident, this may not be an uncertain sentence, because in this case probably is very uh, well known use for to refer the cause and effect. So, when we are talking about language, we also need to understand the linguistic constructs in uncertainty. So, uncertain constructs has been broadly classified into two groups. First is the semantic group, that is usually associated with the modal verbs and the factuality, veridicality, evidentiality, and commitment. We will see examples. And then discourse level uncertainty. Now they have interesting names like weasels, hedges, and peacocks. So these are the uncertain markers, either semantic markers or the discourse markers, that deal with the source and reliability of the information conveyed. So in discourse level uncertainty, so weasels and hedges and peacocks are terms that is not really known to us in that detail if someone is not from the linguistics background. So what are the some examples? So weasels are events with no obvious source, or it's specified only vaguely or too generally. So often in blog or newspaper you will come across terms like people claim that not enough of waste from home uh, is recycled, or passive construct like as has been suggested. So often the question arises by whom, because we are scientists or engineers, right? So we often try to link that there should be, you know, particular person or particular source that we can look up to for references. Then there are hedges. Hedges are the language constructs that make meaning of a statement fuzzy, such as it will include things like approximator. So approximately, probably, or passive voices, or whenever we intensify something like we saw in the last slide, that extremely, many, or de-intensifiers when we say things like a little bit, low, or small. So how small is small? Small may be very different for me than you. I may say like 250 ml milk is a small quantity for me. You may say that that is adequate enough for you. So these quantifiers or these intensifiers or de-intensifiers, they kind of incorporates a vagueness or a fuzziness into the communication. And then the peacock. So from the names, you can understand that these are the polarity induced expression, but the words express some unprovable qualifications or exaggerations. Say for example, when we say a movie is awesome, so awesome we cannot really quantify. So you may say something awesome, I can say it was very poor. You may find something astonishing, I may find something very commonplace. So these are the term that is very hard uh, to quantify, and that's why whenever we do something like emotion identification or say like intensity detection or even in the textbook explaining some concepts, so these terms they make life difficult for the natural language processing engineers. um, so I took a little bit of time in explaining the linguistics background of it, because whenever we want to do any kind of technological intervention, if we want to develop any deep learning model for natural language processing task, we first need to identify the context of it. So these days we often have the practice that we take the data and on it we blindly apply some very convoluted deep learning models. But to actually get good and interpretable and meaningful results that can be generalized across data sets, we must need to identify the linguistic constructs. We must need to understand the phenomena first, and that is how all the legendary models in machine learning and natural language processing have come up in the last few years. So in this paper, we have used dominantly two approaches. The first one is actually on which the title of the paper is based on. It is called the relation aware self-attention based multi-channel CNN tree LSTM. So don't get intimidated by the name. We will refer to it as the RAKE MX CNN TLSTM model. So we have mainly attempted a classification task. So this is a model that we have developed from scratch, and also as a second alternative, we have taken a pre-trained BART model, as BART is now the state of the art reference point, and we have fine-tuned it over the given training corpus for the same classification task. And on top of these two, we have also explored a number of other baseline models as well. So let us look into the model architecture. So if you see on the left hand side, we have the schematic diagram, the architecture diagram, and I will just walk you through it with the sentences. So obviously for a deep learning model, we need to begin with some type of embedding, words or character embeddings. So we have used static embeddings from fast text to word to vec and Elmo. So three different models trained for these three different architectures. And how we will normalize for these stopwords and the very least frequent words, we have only after the stopwords removal from the corpus, we have only incorporated words. Those have appeared more than 5 times, and the rates are denoted as UNK, the unknown token. So it also helps actually the model to generalize for new data as well. And to mitigate the loss due to unknown words, we have also used character level embedding, so that embeddings for new words can be learned. For Elmo, the context-based embedding, because it requires a context-based embedding, it is obtained through a two-layer bi-LSTM language model. So it is a bidirectional LSTM, and on top of that, we have a stacked layer of a character-based convolution network. So if you see, this convolution network is purely on the character level embeddings, and as we have two different channels, so the name multi-channel neural network. Okay, and also this character level convolution network, it has a fully connected layer on top of it, but before that it have a low dimensional projection of the character level embedding to bring all of the two channel embeddings on the same plane. So now the rationale why we use tree structured LSTM, because in a standard bi LSTM model, uh, as some of you may know, that information propagates sequentially. So either it is forward or it is backward. But say whenever we process a sentence, we do not actually do a sequential processing. So TLSTM helps actually to account for the complex dependency linguistic structure, and it also allows richer network topologies. So I am jumping a bit for the sake of time. So in the relation, why we have termed it as relation aware self-attention model, because we have extended self-attention unit attached to the hidden layers to consider the pairwise relationship between the input elements. So the advantage is that we can now model the input as a label, directed and fully connected graph, and this is important for uh, such the complex structure as the linguistic entities, because then we can compare all the input the elements with their pairs. So it also gives an edge over the only general self attention. So for data sets, these are publicly available data sets and you can look up to it. I will not go into the details. So the first one is called website privacy policies. It's a collection of policy documents. Second is the SFU review corpus. It is a San Francisco University, which is a review from movies, books, cars, hotels, and consumer products from opinions.com. And then we have the bioscope corpus, which actually deals with the different biological abstracts. And we have experimented with 3 settings. The first one is the general setting that you do a 70, 20, and 10 sets for training, validation, and testing for each of the individual data sets. And then in the second setting, what we did is to understand how well it will generalize across data set. We combined all the data sets, and then again we did a 70, 20, 10 on this combined data set. And in the third experiment, we have actually looked into the portability of or the transferability of the model. So we have trained on one data set and tested on the another data set. So this result table shows that for dataset 1 and dataset 2, we have our relation, our CNN TLSTM model. It performs better than everything else or when trained on the Elmo based embedding, and only for dataset 3, our BART based pre-trained model, it performs the best. So these are the F1 scores. And for experiment 2 and 3, so experiment 1 is 3 data sets separately. Experiment 2 is combining all the data set, and in this case also these the relation around multi-channel models perform the best. And experiment 3 is the transferability, the training on one data set and testing on another. And in this case also we see that our model gives reasonable performance depending on the train and test set combination. So for some combination like 2 and 3, it gives very high F1 score. For some combinations like 1 and 2, the score is a bit less. So thank you all for listening, and please feel free to reach out to me for questions.
Thank you so much, ma'am. That was wonderful. And
thank you.
Yes, ma'am. Thank you. Thank you so much. Next up, we've got our next speaker. That is Mrs. Ananya. And she's going to be talking about how data science makes its way into agriculture. Over to you.
Okay. Am I audible?
Yes, ma'am, you're audible.
Okay, I'll share the screen.
Yes, ma'am.
My screen is visible, right?
Yes, ma'am, it's visible.
Oh, thank you so much, Sasha. Hello, everyone. How are you all doing? Hope you are all fine and good. and you're enjoying the 4th day of WiDS conference, even me. It's a great privilege for me to be part of this event with these expert co-speakers. So today I'll be talking about topic Agriculture 4.0, or how data science and the related technology is making its way into agriculture. Before that, let me introduce myself, Ananya. I'm a data science enthusiast, Women Techmaker Ambassador and co-organizer of GDT Trivandrum. I am remarkable facilitator, and I love being part of various technologies, various women in tech communities, nurturing communities, and I've also received Outstanding Women in Engineering Award from IEEE Kerala in 2018. So that was a little bit about me. Now let's move on to our session. First of all, I would like to share why this topic, or why there is a need of technology in agriculture sector. As we see the quote in the slide written by Thomas Jefferson, agriculture is a wisest pursuit because it will in the end contribute most to the real wealth, good morals, and happiness. As we all know, agriculture is the backbone of India. It is a major support to the Indian economy. I think maybe 70% or 50% of the whole Indian population taking agriculture as their main work. Now, why am I stressing so much on this? Wait, let me show you something. This is something which I read in a report by United Nations Food and Agriculture Organization, which says how to feed the world by 2050. So why is it like how to feed the world by 2050? Okay, the world population is expected to increase to 9 billion by 2050, which means we need to increase the global food production by 70% to prevent the massive famine. As we all know, we are in a very huge pandemic situation, and every sector of our economy is facing different issues. Similarly, simultaneously, agriculture sector is also facing a lot of issues. We know agriculture is standing next to the line of IT, banking, manufacturing, finance, healthcare, in which the data science is making its entry. And it features several applications in which the agriculture industry could further curtail its wings. Artificial intelligence-based techniques, big data analytics, all address the challenge of agriculture production in terms of sustainability, productivity, etc. And we know there are lots of emerging new applications that can transform the agriculture from traditional farm practices to highly automated and data-intensive industry. Here, there is a huge opportunity to leverage this data science technology to that can explore past data, and that can be used by farmers to make decisions about the crop selection, soil management, planning, logistics, etc. There are lots of challenges in this industry also that I'll be talking later. So that with this, there are lots of opportunity and future also for this sector. Now, there's a brief introduction. Now, I would like to take you through the growth of the sector, a brief roadmap on how the growth has happened along with the industrial revolution. First is agriculture 1.0. Traditional farming practices from ancient time, maybe peasant farming, using indigenous tools, manual labor, low productivity, all those were coming under agriculture 1.0. And then taking advantage of benefits from industry 2.0, the mechanized agriculture or agriculture machinery was introduced, which reduced the manual labor, and also it was contributed to the development of agriculture food supply chain, in which the agriculture products were there. And then agriculture 3.0, subsequently the advancement of embedded system, communication system, and software engineering, industry 3.0 were there, which brought the era of agriculture 3.0, and it was the exploring or starting of precision agriculture, which included yield monitoring, variable rate application, guidance farming systems, etc. Then it's the fourth industrial revolution that is ongoing now. We all know the fusion of emerging technologies, IoT, blockchain, artificial intelligence, data science, all those brought up the agriculture 4.0, which provide the opportunity to transform the industrial agriculture into next generation, high degree of automation with data-driven intelligent decision making, and also agriculture food supply chain efficiency, food safety, and use of natural resources. And what is the future? What is the future of the sector? As we know, 4.0 is started. There is a long way to go with lots of opportunity and future. It is in our hands how we utilize this for the betterment of the sector. This is the picture depicting the roadmap of industrial and agriculture revolution that I was talking about, agriculture 1.0, agriculture 2.0, 3.0, 4.0, and the various, how the transformation has happened and where we have reached now. Now I'll be taking you through more about agriculture 4.0, the various technology in agriculture sector, the use cases, the challenges and all. So starting with Internet of Things, I would like to talk about SAGWIN that would be realized through the combination of remote sensing, drones, smart agriculture vehicle, WSNs, mobile crowd sensing, and establishment of this remote sensing station would be able to provide full coverage of acquisition of agriculture information that is efficient for crop production, forecasting, yield monitoring, etc. And the space air ground interface integrated network SAGWIN, it's used for ubiquitous agriculture sensing and networking. And I should really say thanks to advances in communication technology, because different types of wireless networks, 5G, LoRa, Sigfox, Zigbee, Wi-Fi, it can be chosen to meet the diverse service requirements in agriculture application. And there are a lot of unmanned aerial vehicles that are equipped with hyperspectral sensors, multispectral cameras, and other novel instruments that can provide the emergency responses, along with agriculture sensor nodes, autonomous farm vehicles. All these are responsible for the precision farming. The agriculture application and use cases of IoT include precision farming, livestock monitoring, smart greenhouse, fishery management, weather tracking, etc. Now, AI and big data in agriculture. This is some of the use cases and application of AI and big data in agriculture that I would like to talk. First is the crop data management system. And AI is also being applied to applications in agriculture such as agriculture decision support system, agriculture mobile expert system, agriculture predictive analytics, and also animal wearable using computer vision system. And one important thing is mobile expert system, which is a key application of AI in agriculture, where farmers easily use their smartphone to identify the diseases, pests, soil problems, etc. And one thing that we all are familiar with is a TensorFlow, a very good ML platform for solving these challenging problems. And we also know using TensorFlow, we are able to detect the plant diseases, plant leaf diseases in cassava plant. Finally, AI. In addition, also this progress of farmland can also be tracked by satellite imagery, okay, which is analyzed by AI engine. Mobile apps simultaneously visualize the results so that farmers could understand the status remotely. And at FarmerNote, what happened is that they are helping the farmers identify the unhealthy crop regions and water stress in their fields through the satellite imagery. Finally, AI-enabled agriculture predictive analytics are capable of forecasting weather condition, predicting crop yields, modeling agriculture market volatility, performing price estimations, etc. Next is a big data. Big data in agriculture play a key role, and the data-driven agriculture industry would profoundly transform the production and consumption behavior. For instance, we were talking about ADSS, mobile expert systems, agriculture predictive analytics. All these rely heavily on this big data, which can provide smart recommendation to the farmers towards the precision agriculture. And major role of big data is in agriculture food supply chain management is very essential, especially during this COVID impact. The supply chain has been very inefficient, and big data can play a key role in that for this imbalanced supply and all. Coming together of the cloud computing and big data has ensured that farmers have sufficient data points to make good decisions. And the last one technology that I like to talk is blockchain in agriculture. The two key applications of blockchain in agriculture is smart contract or distributed ledger technology and cyber security. Smart contract for agriculture, there are lots of blockchain startups such as AgriLedger, AgriDigital, AgriChain, and Ripe. But they have proposed a solution for this agri supply chain management. And need of cyber security in agriculture technology is that we all know cybersecurity is very important in every facet of society, including our daily life. Not to mention the agriculture sector is very important. So there are three major attacks that can come for this agriculture sector during this technology intervention. First is data integrity attack. Data integrity attack through data tampering and rogue data injection are the first thread in precision farming application. For example, I would like to say about a use case, smart irrigation system, that would schedule the wrong watering runtimes because of this wrong data is inputted. Then what happens? It can either cause huge irrigation or no irrigation at all. So data integrity attacks is the first attack, and the second one is confidentiality attack through packet sniffing or system backdoor. What happens is farmers would really suffer from a great deal of negative emotional impact if the sensitive data are disclosed to third parties. So that is a very important attack that occurs in the cybersecurity in AgTech. And the third threat is agriculture IoT network attack through DOS systems and malicious reporting and other attacks. So we are using a lot of sensors, sensoring nodes, embedded system. So if there is a wrong reporting or reporting because of this denial of sleep attacks, even cause disasters in autonomous farming and livestock production. Hence, these wireless network defense and privacy protections are very crucial in agriculture domain by we are incorporating technology in agriculture. Now, this is something very important because how COVID-19 has affected the agriculture sector. The coronavirus-led lockdown has hit the farming community and it has impacted the livelihood very adversely. And as I said before, importantly, the agriculture value chain in India has been adversely affected by COVID-19 crisis and the resultant lockdown. And there are other factors, that is, as I said, inefficient supply chain, shutting down of local markets, restrictions on transport and logistics, difficulty in resource management, labor shortage, lack of market access, and along with this, various states of our country is being facing unpredictable climate change also. And for this, I would like to discuss two recent projects. One is the project that I have been doing in the previous year, and other is my colleagues project in our university. Our colleagues project is very inspiring because one that really solves the opposite issue. The project is automated irrigation and crop management system or resource management. This really helps the labor shortage issues, especially during COVID crisis, because it solves with a real-time monitoring of farm, also the crops, accordingly the irrigation can be done. The prediction algorithm is run successfully. They have predicted with the soil moisture, temperature, pH. Accordingly, the irrigation system or irrigation pump is turned on and off, sprinkler is turned on and off. This can reduce the farmer intervention in the farms because especially during this COVID-19, the labor shortage are there, so that they can remotely analyze their farm rather than coming there. And this real-time results and status are obtained in a web page or application for the farmer also. And this is their project, and what they have done is they have incorporated the big data analytics also to improve the supply chain. And along with that, farms produce hundreds of thousands of data points, as we know. And with the help of AI, farmers analyze these variety of things in the real time, such as weather condition, temperature, soil condition, etc. So this was their graph, like the predicted value of temperature and soil that I obtained. And this is the next is our project that we were working on in previous year. What we proposed a model that predicts the soil series and land type, and according to its prediction, it can suggest the suitable crops by machine learning algorithm. So we were measuring the soil property using some of the sensors, and that was given to the machine learning platform, which is used to the prediction of soil, crop, and fertilizers. And we all know, rather than the 7 basic types of soil in our country, in various states there are different types of soil series and soil types. Determining these types easily on real-time basis is very hard for the farmers, that they have to analyze it with the help of laboratory and taking huge time along with chemical interventions and all. So what we did was, we were determining the types easily on real time, helping the farmers to take a wise decision on crops and fertilizers. And along with the soil analysis, we were suggesting a list of fertilizers according to the nitrogen, phosphorus, potassium values. And in this soil testing, human efforts can be reduced by monitoring the quality, and farmers can also test the soil multiple times during their cultivation process. So this was our project. This is a sample scatter plot that we obtained after prediction for fertilizer, soil, and crop using machine learning algorithm. We were using random forest and GBM classifier to do this. Now, this is something very interesting that I would like to share. How the Agritech startups are helping farmers thrive during COVID-19 lockdown. However, we have witnessed that agriculture cannot solely live on the traditional methods now, and that desperately needs a large technology intervention to resolve these issues. And the fundamental issues, as we discussed, first is the supply chain. and then soil quality, water shortage, irrigation system. All these issues can be solved only by bridging the gap with high-end technologies like blockchain, AI, remote sensing, etc. And what happened is Agritech startups in India have been making multiple changes to their process to tide over this impact, COVID-19 impact. And they have been working on helping farmers to improve the productivity, getting access to raw materials, farming equipment, streamlining supply chain. Also, they are providing end-to-end farm management solution to train the new age farmers to impart the technical farming and run a farm efficiently. So implementation of this artificial intelligence and IoT in agriculture during COVID-19 offered a more efficient ways of producing, monitoring, selling crops, etc. And this is something I read recently. As per NASSCOM's 2019 report, India is a home to more than 450 agritech startups growing at a rate of 25% annually. And this is a clear indication of agritech industry's growth potential, right? And this was, I was talking before, industrialized agri-food supply chain that is really affected because of this COVID-19. And traditionally what happened was business to consumer was there. And with the impact of intervention of these IoT and artificial intelligence, O2O, social commerce, customers to customer, all these latest agri-food supply chain efficiency has been implemented. Then what are the challenges? As I said, there are a lot of challenges by implementing this technology in agriculture. That is, for our project, what are the challenges that we faced was like, it was very difficult for us to get the data. Data is very inaccessible and related data on agriculture is very less than that of industry. And also the hardware equipment, sensors, there are a lot of inefficiency in sensors that are available currently, and lack of digitalization in agriculture is also there. And as I said, cybersecurity in agriculture is very important because privacy protection issues are also there, and data interoperability is essential. And all these things are challenges that we have to solve in the future, and they are a great opportunity for us to work on. And one major thing is the lack of digitalization is the shortage or gap between our experts and between the farmer, and that is one challenge we really need to solve, and agritech startups have started working on it. And what are the opportunities and futures, like students who are going to do projects, or those who want to try out, want to work on this, have a huge opportunities and challenges to solve in this sector. Even our government needs such innovative solution for the sector, so there is a huge opportunity and future for data science and agriculture. Recently, I read Ernst & Young in its latest report have claimed that Indian agriculture sector will rise to 24 billion within next 5 years. So the report says that Indian agriculture move towards digitalization. The agriculture sector will become more diverse and will attract more increase in capacity of supply chain. And as we know, global crisis has brought us all together like never before. And given this adversity and crying need for urgent and smart solution, we have to see the best minds to work at propel innovations. And the dynamic of agriculture is going through a starting phase, and it will change the agriculture sector in coming time. And that could well bring another green revolution like transformation in India. And what Agtech is described as a fourth agriculture revolution. It's a marriage of data, farming, technological innovation that will further transform the industry and help us to achieve so far unrealized productivity. And now I would like to remember this quote by Bill Gates. I have seen the first hand that agriculture science has enormous potential to increase the income of small farmers and lift them out of the hunger and poverty. I would love to contribute and collaborate in this. If you would also like to collaborate and discuss, let's connect. This is my contact details. Let's together bring in smart farm practices to improve the agriculture sector. Stay home, stay safe, be healthy. I was going a little bit faster because I have to complete it within the time. So thank you so much for listening to me. Thank you so much.
Thank you so much, ma'am. That was wonderful.
Thank you. Thank you.
Yeah. So we've got our next speaker lined up. That is Miss Charmi Chokshi, and she's a machine learning engineer at Shipments. And today she's going to be talking about distributed data and personalized predictions. Over to you, ma'am.
Thanks, Shashank, for the kind introduction, and Usha for organizing the Women in Data Science Mysuru. It's my pleasure to be in this platform. So let's quickly dive into the field of decentralized AI, specifically federated learning and federated computation. So in continuation to previous talk by Ananya, she was talking about that in the agriculture industry, when AI is taking it feeds now, we might need sensors on the fields, on the farms, and then those sensors would collect some of the data and then send it to someone else. Similar, the mobile devices we use, the webcams, and in the near future, in less than a decade, when we would be using self-driving cars, all the data would be born at the edge. Whether it's your location history, the pictures we are taking, the movies or streaming videos you are watching, the weather data which has been collected in your phone, or what are your likes and dislikes based on your social network profile. All of these data is being generated on the edge devices, on your phones and on your laptops. And there are a lot of different advantages of that, because since all the data resides just in your phone, it preserves the privacy of you and your data. Even if you are not supposed to send this data to a third party, to a server or a company, your battery life would be longer. And imagine if you have all the parts of the world in your phones, in your Google Maps or Apple Maps, you would not require to go online to go from a destination, go from a point A to point B. You can work offline anywhere and anywhere you want. But is that even possible? Apart from the privacy, what about the analytics and personalized learning? Once we send this data, our likes, dislikes, our behavior to a third-party server, the ML and AI model residing on that end learns from our data and then send us the personalized recommendation. The movies recommendation you can get on the streaming platforms, or the what kind of things you shall buy on any e-commerce site, or what kind of food you should try next on the food apps. All of those are learning from your past history, from your past data. And then to get the personalized recommendations, it is necessary that the data which is residing on your end has to go somewhere else. And there is a big issue of privacy, because the server, that company would know almost everything about you, and that can be dangerous, right? Giving you one more example of a Gboard, a keyboard by Google, where you type your passwords, you type everything, like starting from emails to posts to chats. You can use gesture controls. You also use the next word prediction on the keyboard. So there is a lot of things with Gboard is giving you as different features. But do you know how it is learning, how it is predicting these 3 next words, or how even if you swap your thumbs and fingers anywhere on the keyboard, it is able to understand that what you are trying to predict? That's all because of the data it has captured of you from your devices. But in a private manner, you are not losing your privacy. And that's what we are going to learn today, that how the Gboard understands that what 3 next word I shall predict, so that it will be beneficial to the user, what kind of maybe the products I should recommend to someone else which can be beneficial to them, with preserving the privacy of the user. All of these is connected with federated computation, subfield, which we are gonna learn first of all today. So understand that there are different client devices, the edge devices. It can be your phones, tablets, self-driving cars, or sensors in the farms. And then all of these devices or the sensors, let's assume that have captured some data points. For example, these data points are the highest temperature measured of a particular day. So for this device, that is 68. These are all just hypothetical numbers for this device and the following ones. So for this, it's 70.5 and so on. Now, we want these data points to send to the server so that maybe the weather prediction model the server is creating can learn from these live data, this live data points, that if the temperature is 68.0 today, what shall I predict for tomorrow? Whether the prediction of the whole entire month I have done, is there any tweaking needed that or not? For that, if we just send this individual points to the server with respect to all of these devices and their location, the privacy of the user won't be preserved, right? Because that would definitely know that this is the address of the device and this is the temperature. It corresponds to the person A. For that, what federated computation is doing, it aggregates all of these data points. For this example, they are just 4, but it can aggregate millions and billions of data points, and it is like it can be varying. For this example, let's assume that it is aggregating these 4 numbers, and the average of this 4 number is being passed to the server. If you don't want to take the average, there are different kinds of other computation which you can do, like squaring and then averaging, or just simply adding, taking the maximum out of it or minimum out of it, and so on, which solely depends on the problem and your solution. So here we had maximum temperature of day for each of these devices. We aggregated them and sent it to the server. Now, an engineer residing at that third party, at the server end, has written a small program that if taking a threshold, or let's say 70°F, if the reading of particular day is greater than the threshold, give an output of a 1, otherwise 0. So firstly, we had some inputs for each of these devices, which was containing the maximum temperature. Now the engineer has wrote a simple, easy program of if the reading is greater than threshold, pass it to 1 or the 0. So now this program, the copy of this program along with the threshold is being passed to all of these different devices. And then the computation, final computation is being done at the edge devices. Now, you might be wondering that how this threshold of 70, the engineer or a program get into. It's not any wild guess. If you remember, we had seen an average temperature of all of these devices, which was around 69.5. So based on that, the rounded threshold value of 70 is being chosen as a threshold. So what just happened here? We aggregated data points, send it to the server. Based on the aggregation value, we choose a threshold, and now that threshold along with this simple code is being passed to all of these edge devices so that they can implement that code and then understand that whether here is a very simple code which we have written to predict 1 or 0, but then we can also pass in to model that what would be the temperature for the next whole week. If this is the data points of, let's say, health related data, that the person using this device has run 10,000 steps this day, or a person containing this device had heart rates of 72. So there was the maximum of this day, or the average of heart rates measured across different timestamps of a day. Or it can be some data points regarding the share market price, or agriculture data, and so on. So all these data, which are privacy preserving, which should not go to any third party, but still we want the personalized recommendation using that, is where federated computation is being used. So you might be wondering that we are sending the aggregated data. So can't anyone, an engineer, can then decrypt that data by doing the reverse computation? No, because all the data from the start is being encrypted, and then even the private key for that encryption is not shared with the server. So your data, your health data, your monetary transactions data, your temperatures data, all of that would be encrypted from very first, and then the aggregation is sent to the server, and then the updates based on those values is being sent to your edge devices. Okay. So how is this different from MapReduce? If you have ever known about this in OS, then you might know that we are first of all splitting the data points, then we are aggregating, then we are splitting that again. That's something similar to MapReduce, even that we use in data science field. But there are some of the challenges of federated computation, such as limited computation, internet data availability. We talked that some data points are being sent to the server. But what if the data points are not even captured at in device, or then device is not able to share those data points to a server because of the network latency or internet issues? And then there aren't just one or two edge devices, or there are millions and billions of there out there. So how to choose some of them and then aggregate them and then do the updates on that? So there are a lot of different challenges in this field, and that's where federated learning, a subfield of machine learning which works on decentralized data, came up with, which specifically works on edge devices, and it gives the state-of-the-art personalized recommendation with the with preserving the privacy of a user. Now, all the typical machine learning or deep learning models which we code, all the training data or the validation data would be on our system, on our local system, or in some hard drive, or you might have stored that on the cloud servers. But here, we are not using a data which is stored in one centralized place. Here we are using data across millions of devices out there in the world. So the data is centralized. So how many data points to choose for each iteration of model update, and then whether that model update is even true or not, whether they have any anomaly inside it, whether this update is correct or not. So there are a lot of different challenges which people are also working on in this field. But let's now understand that out of this millions of devices, how some particular devices are selected for an iteration of this model update. There are three different things: that mobile has to be connected with charger, the internet connection should be on, and the mobile is not in the use state. So whenever you are not using your state, like around the midnight, or it's connected with the internet and the charger, those devices would ask server that, hey, I have some data point capture for today. Do you need me now for the further computation, so that the model which I have for recommendation can be updated, and then the end user can get more personalized recommendation? But let's say the server says, no, I'm currently doing some other computation. You can connect with me at some different time. So again, at 12 a.m., the device didn't connect with the server for this model update. But then after, let's say, 15 or 20 minutes, it again got connected. And what happens now? It had data points. It had one initial training model as well that was maybe built on TensorFlow or PyTorch or any other ML model which you can think of. It had an initial copy on which it was currently using. But now it is sending this initial copy to the server, and all of different edge devices will do the same thing. And then based on the aggregated data points, a model update would come up that, taking an example of, let's say, word SORRY, sorry. Okay, the dictionary, the sorry, how it would be written inside the dictionary on basically on the basic model which was trained on. So the spelling would be SORRY. But nowadays, the language which we are using we would write sorry as SRY or SRRY or some of the variants of it. Now, a lot of different people are using the same kind of language, and that data point is now being sent to the server that insert one more word which has now come up in the world, which is SRY, which is highly resembles with sorry. And that's something new word which people use a lot these days. So how about if we for the next three word prediction, instead of sorry SORRY, we give a user SRY as a prediction, because it is highly likely that a user would click on that and it would be a beneficial recommendation for them. So even in the world, when a lot of devices are having those data points, the combined model would now be with different kinds of these internet slangs and internet shortcuts like lol, ruffle, and so on. So now the model would understand that I was previously trained on some different kind of data points, but now since the other kind of data set is also being generated, let me update my data points, let me update my model, and then send a copy of that updated model to the initial device. So this is how the federated learning happens. And some of the applications of that which Gboard is currently using is, if you have ever noticed that you can, for those three-word prediction, we can also get an emoji as a prediction that this part is lit. And now after writing the word lit, fire emoji is being presented to a user that do you want to add this to your system. And the bottom histogram which you can see in this slide represents that what are the highest emojis which people around the world are using. And after the integration of emoji prediction on the keyboard, Gboard did the analysis, and the analysis was that more than 70% of the users started using emoji more and more, because it is now coming up for the next three-word prediction. So the lazy users are just thinking to click on that quickly. Some other examples are Jiffy. So when we search for a phrase, let's say good night, possibility that someone would search it with just a word night, or let's say sweet dreams, or good night in some other different language, which is French, Spanish, Gujarati, Hindi, so on. So the model is now learning from different data points that this person searched for good night. I gave him or her this 5 different GIFs, which the model firstly thinks that can be of a good night. And if that person, after searching goodnight text, clicks on the very first GIF or any of these 5 GIFs, what does that mean? The prediction which this model is giving are true. And that's why the user are clicking and sending those GIFs. So the model is now being more and more confident that whenever I give this 5 predictions for text goodnight, it is highly likely for a person to click on that, because all the predictions are really true for that. So Jiffy, a company, is also using federated learning to learn from end users' behavior, how they are searching and how they are typing, and whether they are sending the recommendations with that Jiffy gives you or not. So it understands from the segregated data points and how the query, how users are querying over it. Again, going to some internet worlds, slangs which we are using, which can have typos, or some of them are non-English words or abbreviation, and so on. So Gboard can also predict these kind of words now. That's because of the federated learning. So this is it. The crux of this session is that using federated learning and federated computation, we can learn from everyone. A model, a server can learn from every edge devices without learning a particular thing about any one person. it won't know that Usha is using ha a lot, but it would just understand that there are, let's say, 100 devices out of 150 in this training point are using a lot in their day. So that's maybe a word to be added. So this is how we can learn from everyone without learning about anyone. So that preserves the privacy of an individual and even gives personalized recommendation. So if you now want to kickstart your career in this field or are planning to learn more, giving you a small exercise that have a look at your smartphones or just at your lives and think, is there any app which can embed federated learning into it? During this presentation, I give you a lot of different examples like health data, monetary transactions data, or the agricultural data. All of those are really very private, and the third party should not have direct access to those data points. But then building a machine learning model to predict the share prices or whether this person would have coronavirus in future or not, or different kind of medical predictions. Learning from that data points is needed, but then the privacy of that user should be preserved. So can you spot any app which can embed federated learning into it, or any of the apps which are already using this field? Do let me know in the comments box of YouTube, or you can connect with me over LinkedIn, GitHub, Twitter with the username CharmyChoxy. And do let me know that what do you feel about this field, and are there any apps which you think can be useful? Hope you enjoyed this session and got to learn something about this field. Thank you so much for having me, and keep learning. Happy learning.
Thank you so much, ma'am. That was a wonderful session.
Thanks a lot.
Thank you. So we've got the last speaker of today, and that is Ms. Sabari Lakshmi Krishnamurthy. Ma'am is the head of engineering, data, and machine learning at Saturam. And today she's going to be talking about continuous delivery of data pipelines. Over to you.
Thank you, Shashank. Is my screen visible and am I audible?
Yes, ma'am. Your screen is visible and you're audible too.
Thank you.
Yeah.
So before I get into today's presentation, that was a good talk that we listened to earlier on the federated learning. So my talk is going to sort of cover why a continuous delivery is needed on a data pipeline, which is going to serve some of the consumers is one of the use case that the previous speaker spoke about. So very good afternoon, everyone. I am really glad to be here today as part of WiDS Mysuru 2020. And I'm going to talk today about the importance and need of having a reliable build system to scale the delivery of data to different stakeholders. So a brief about me. I am Sabari. I'm an ex-IBMer with an industry experience of 14 years. And I've also contributed to software engineering on cloud DevOps. Currently, I am the head of engineering in Saturam. I lead development of products on data and ML. Specifically, we are working on a SaaS offering called Qualdo, which helps in monitoring production model and data quality issues. I am passionate about what I do and I love challenges. So before we dive into the presentation, I just want to take a minute to give a brief about the company. So we are an advanced data engineering company headquartered in Palo Alto in the US, having expertise across the entire data lifecycle operations. We help our enterprise customers to convert data assets and feeds into high quality data useful for analytics and ML. So we are a growing company with 21 customers across the globe. All right, so continuous delivery, that's what today's topic is about. So some of you might already be familiar with this term continuous delivery and probably the principles behind it. Since it's a virtual presentation and I didn't get to know about the audience, and for the sake of any beginners in the audience, I'll just want to take a minute to introduce what a continuous delivery is about. So the definition I have presented you here is from a book called Continuous Delivery by Jess Humble and Dave Forley. So typically in a software delivery world, continuous delivery is the ability to get the changes into production safely, quickly, in a sustainable way. So if you observe this definition closely, there are three important keywords: reliable, repeatable, and automated. Generally, we can map this definition to the usual software delivery because we are always used to it. But continuous delivery of data as a concept is relatively new and is probably gaining popularity in the last couple of years only. So if you take in a simple definition, a data pipeline is nothing but it moves data from one source to another, but they are often a critical component of a business information system. So unlike software where it's only code, in a data pipeline, there are two components involved. One is code and another is data. So now let's try to apply the definition that we learned about continuous delivery to the data pipelines. So for a data pipeline, continuous delivery means reliable delivery of data to different consumers or stakeholders like data scientists, business users, ML models who are which is using these data using code in an automated way at any point of time. So these concepts also apply to machine learning pipelines, just that a machine learning pipeline will involve a model as well in addition to code and data. So why is it important and how do you scale your data engineering? How can you scale your data engineering with continuous delivery? So we all know that how everyone tries to leverage the data to bring out the actionable insights. The presentation that happened prior to this is one such example. And I think you might have already listened to different speakers talking about different use cases of how data is getting used in data science, be it in agriculture or in medical science field and everywhere. So everywhere, everyone is trying to use data to bring some actionable insights. So companies need a faster way to respond to the market demands. What they are looking for is a way to quickly analyze and make the best decisions from the data. So they are under immense pressure to deliver faster and high quality output. So what is it to do with continuous delivery? It's the need of the hour to have a streamlined process and automation in place to feed these downstream consumers, and continuous delivery is the way to do it. And if you think about it, there is one another point also we have to consider. Now we all know that data keeps changing. That's its nature, and it always carries a messiness with it. This can easily break a production pipeline. For example, when I built a pipeline, the source that I was ingesting data from could have only had 20 attributes, but now it can have more, less, and this kind of scenarios is unavoidable, and it will easily break a production pipeline. Similarly, we humans are prone to make mistakes when we develop code. So imagine a scenario where someone has developed a pipeline to do an incremental refresh, but just for the sake of testing purpose, he has hard-coded something in his code and he just simply forgot to change it when he moved to production. Now the data will get loaded in a place where it's not meant to be. So just imagine the impact it's going to create. As you build complex pipelines, there will be errors that are prone to happen. Now, how do we catch these problems ahead of time and correct it? So we definitely need to have a reliable, continuous delivery process in place to catch these problems ahead of time by having required checkpoints in place. All right, so I have briefly explained what continuous delivery is about and how do we apply it on a data and why is it important and why is it mandatory for an organization to have this in place. Now, what I'm going to talk here is a broader approach on how you can get started with implementing a continuous delivery for data. My intention today is to lay out the essential blocks one might need to consider to have a continuous integration and delivery system. So this is a general guidance, and the way the processes get defined will be specific to your domain. So if you broadly see, there are 5 blocks: environments, pipelines, tool, testing, and monitoring. So we'll go one by one and see what each of these block really mean. To start with, environment. So if you are used to software delivery, you might have you might be already familiar with having a concept of development environment, staging environment, and production environment. Data delivery is no different from that. So it's definitely recommended to have different environments like dev and staging for testing the data pipelines before they get into production. So each of these environments serves different purposes. A dev environment is needed to quickly catch and evaluate the change. So this environment should be optimized for a quick test run. Don't be worried if things break here. And similarly, coding best practices ought to be followed when you are developing your data pipeline, and any violations in that should be caught using tools like SonarQube at this stage. And this helps in delivering a clean and security vulnerability free code. So it's also recommended to use a sample or mock data in a development environment for efficient testing, so that the stability of the code base can be quickly analyzed. A staging environment is maintained more like a production environment. So maintaining a staging close to a production environment helps to minimize the kind of issues that we might uncover in production tomorrow. So testing in staging is more rigorous when you compare to dev, and the data used here also will resemble production data, or a sample of production data itself can be used here. So we'll talk more about it a little later in the presentation. So once the pipeline successfully clears the tests in this stage, a deployment to production can be confidently triggered. So it's important to have separate configuration files or things needed to capture the testing data or testing infra needed for these different environments, because one can easily lose track if they don't maintain these things separately. For example, things that are potentially should get into one place in a staging can go into some other place if these config files are not maintained properly. So next pipelines. So these are the critical portion. So you definitely have to organize your pipelines in a self-explanatory and structured way, so that it's very clear on what the pipeline is doing, and the version control system. So the pipelines can be grouped by various approaches. One way to organize is based on the source they read data from. For example, all pipelines reading data from MS SQL server can stay together. Another way to organize is to group the pipelines based on to whom they deliver data to. Again, for an example, pipeline sending data to a specific line of business can stay together. So it's purely up to you to define how these grouping should be. But the recommendation is to have a definite grouping and maintain separate repositories for this logical grouping. So within the repo, store the pipeline code and test cases separately. So if there are any common modules that are used across all these pipelines, it makes sense to separate it out as well. It helps you with better maintenance of code over a period of time. And similarly, if you have any code for infra provisioning and things like that, it should be definitely maintained in a separate repository. And also, it's a good practice to follow a tagging mechanism to release the pipeline code into production. So this will definitely help you in tracking back any production failure to the version of code that caused it. And it will also help you to fix it immediately. Next is on the tool sets. Identify the right tool sets which will work out for you. What I've listed here are some of the popularly used tools in the industry, and this is not a mandate that this is the only tool set choice. So go with what is your need and pick a tool of your choice. But Jenkins is a very popularly used CI/CD tool and is also rich in plugins. Similarly, Kubernetes is a popular way to deploy services nowadays, and Kubernetes is also available as a service on all the clouds. And Terraform is yet another powerful infra provisioning tool. It's open source and it's very easy to use. So next is yet another important block, which is crucial for continuous delivery: test cases. So you need tests for both your pipeline code as well as for the data. Tests like a unit test coverage is mandatory for the data pipelines also. This you must be already familiar with as you might be writing it for any software delivery. Similarly, any basic tests that will check on the validity of the pipelines are also equally important to have. For example, a basic rule in Airflow DAG is that there cannot be any cyclic dependency of task. So such checks should be done early to catch if there are any validity problem in the pipeline itself before they get into production. So these are one set of tests that apply on the code. So next is a set of tests that apply on the data. So they are critical because they are going to catch you the problems in data that anyone might find, or people in the downstream consumers might also find. So the definition of these test cases is purely dependent on the functionality of your pipeline. For example, you should have tests to check, do we have required files or data available for ingestion? You should have a test to check the total number of rows that is getting written into a destination. Similarly, you should have a check to have, do you have necessary columns that are present for you to proceed with the pipeline? So this is one set of data related tests. The next set of tests should be little more in depth to verify any transformation logic that is applied in the pipelines. For example, is my data getting typecasted into the right type that my consumers are expecting? Is the data in a format that is in a format that my consumers are expecting? So try to have an exhaustive list of tests here, as they are going to help you to catch any data related problems later. Stronger your tests, more issues you will find early. So there is another important aspect here, which is called as a test data management for you to succeed, because for you to effectively test your pipelines, you need test data. As I mentioned earlier in the presentation, on a dev environment, we can use mock or dummy data or synthetically generated data. But these data cannot appear magically. So you need to have necessary scripts in place which will generate this data as your pipeline needs. There are some good Python libraries out there for synthetic data generation, and these scripts also should be properly organized under the respective pipeline repository. So on staging, I mentioned that the data will resemble production data. Again, you need to have necessary script and infra in place to store a decent sample of production data. So now one question that might immediately pop up is that, why can't I connect to the source directly? No, it is never advisable to connect to a primary data source from a staging environment, as it may put unnecessary load on the source system. Also remember, production data is likely to change often. So whenever that happens, our staging data set also needs to be refreshed so that we are in sync and our tests are reliable. So be extremely careful when taking a copy of production data. So the next important block is monitoring and alerting. So this is critical because when things go wrong and we know that it will happen, so we must be notified so that we can respond quickly. This also should get tested out in staging before we put it into use in production. So what I have listed so far are some of the important blocks to consider. And if all of these blocks are properly designed and done, then you will have a reliable, repeatable automation in place to deliver high quality and timely data. And as it sounds, you might come across challenges in this process. To begin with, if you have a legacy of pipelines, there might be a need in the people's mind shift change to accept this process and excuse me, and understand why it's important, so that any process doesn't serve its purpose if its importance is not understood. So similarly, on the test data management side, you might face a challenge of if I duplicate the data, what if it results in an infra duplication and hence the cost? So you need to see how this setup can be created in an optimized way. So there are ways to achieve it, but none of these challenges are unsolvable. The benefits you get out of this by having a continuous delivery system in place finally wins over. So we at Saturum, we have always been helping our customers with advanced data testing, as they are the key to scale your data engineering. We also have two great products to assist in the modern data lifecycle. Piper is our ML augmented data management product to enable AI readiness faster and smoother. Qualdo is our ML model and data quality monitoring product to enable high-stake data quality issues. So if you have any questions, we are here to help you out. You can reach out to us and we can help you with assessing what you need to do a high-quality data engineering. And that's all I had. I hope the session was useful and interesting. Thank you, Usha, and other WITS organizing team members for this great opportunity and coordinating really well today. Have a good day, everyone. Stay safe and enjoy the rest of the day. Thank you very much.
Thanks a lot, ma'am. It was a wonderful talk. We are grateful to have you here today. So, on this note, we would like to render a heartfelt thanks to all speakers out there for taking out time from their busy schedule and being a part to embrace this celebration. We thank all the universities in the NIE, GSS, GSSS, and JC for taking this opportunity and support us tremendously throughout. We'd also like to take this opportunity to thank each and every one of the for helping us organize and ensure the peaceful conduct of this event from the start. So we have our further events coming up soon. WiDS Mysuru is an 8-day event, so the next event is scheduled on 19th of September. Kindly subscribe to our YouTube channel to get all notifications automatically. Please RSVP for the event if you wish to receive a certificate of participation of the event. A huge thank you to all of you all for being a part of this event today and joining us. Hope to see you all soon in our next session awaiting you. Do not miss it. Check on our meetup channels and you'll be able to get all the updates there. So we're waiting to see you and be a part of an amazing session filled with zestful speakers marking milestones in data science. So thank you and have a great day.